Hello, and welcome to another Into the Terminal. Today we're going to be talking about Logical Volume Manager and troubleshooting it. So let's just jump right into the terminal. To start off with, in these episodes, we're taking a look at our toolbox to start off with, right, as part of our critical path. So when we're talking about Logical Volume Manager, there's really three different abstraction layers between the devices and your data that you're storing in the file system. There is the physical layer, which you can look at with PVS. I have one physical volume, one disk device that's part of my logical volume manager setup at the moment. It's DevSDA2. We can look at the volume groups that are stored across these physical volumes with VGS. I have one volume group called RHEL, um, and a little bit of data there. And we also have LVS to show you the logical volumes stored within it. I have two logical volumes stored inside that volume group, which is held on that one disk device. That logical volume list is the root logical volume and a swap space logical volume. PVS, VGS, and LVS, those are three very quick and simple commands to get you going, but there's some longer data commands too. So especially if we start talking troubleshooting, knowing more about these devices is key. So we have PV display. It'll tell you the physical volume's device name, the volume group it belongs to, the physical extent size. So that's how much disk space is individually allocatable on this physical volume. We can allocate as small as 4 megabytes to a logical volume. The total physical extents on this device, which is about 19 gigs, we have 4,863 extents. Free physical extents, none of them are currently free. They're all allocated. Just like we had other commands that talked about physical volume, logical volume, and volume group, same thing is true for the displays. So we have a VG display. Our one volume group called RHEL is an LVM2 formatted volume group. It currently has two logical volumes. That's what cur_lv means. They're open, meaning they're currently in use. There is one physical volume, current and active. Our overall disk size is about 19 gigs. Our physical extent size is 4 meg, and then we get a little usage data. All right, and likewise, we also have LV display. So we have two logical volumes. The first one is a swap logical volume used for swap space. It's currently 2 gig, right? LV size 2 gig. Under dev_rel root, that's the root logical volume, has all the rest of the disk space for this machine, and it's about 17 gig. One other thing I'd like to call your attention to is in both of these, you have an item called segments. And that's going to be important later. That's contiguous blocks of disk storage used to store this logical volume. All right, so the VS, right? PVS, VGS, LVS, simple one-line outputs, summary information. The displays, a lot more information about how the disk space is being used and what component devices are in it. You may have started to sense a theme. So it turns out that there's a whole bunch of PV something commands, right? PVS we saw, PV display we saw. We're going to maybe take a look at PV move today as well. We're also going to use PV create. So these are the physical volume manipulation commands and volume groups. There's also a VG something dealing with your volume group made up of physical volumes. These are the things you can do to it. And so we're going to be VG extending today. We will possibly be doing a VG reduce today. We'll see if time allows. Just like there's a PV something and a VG something, well, guess what? There's also an LV something. We're going to be taking a look at LV extend today for sure. We'll also be looking at maybe LV create. We'll see again if time allows. So there's a whole bunch of logical volume commands that kind of build out your toolbox for working with logical volume management on RHEL. All right, that's the critical path. What's our toolbox? These commands to control physical volume level stuff, volume group level stuff, and logical volume level stuff. So you may have noticed that I'm on my own today. Nate is at meetings. We're going to take a look at how things work in volume management. You'll recall that earlier in the series of troubleshooting, I said something like, my friend who's an ops wizard used to say, if you don't understand how things work and what it's supposed to look like, how are you going to troubleshoot it when things go wrong? Or how are you going to know what to do when things aren't working right? So let's take a look at our whiteboard. And I've already preceded it with a little bit of content. This is what my machine currently looks like. I have DevSDA, which is the primary disk for this machine, and I have DevSDB, which is partitioned, but there's nothing stored on it yet. All right, on DevSDA, there's a small, like 1 gig size boot partition that's a standalone file system. And then what we saw in the critical path was we were looking at our volume group, and it said that there's one physical volume, DevSDA2, and then when we looked at DevSDA2 is actually being used to store two different things. So it kind of looks like this, where what I'm putting in orange is a better description of this color. Root. That's all my file system information for this machine currently. And then there was also down here in green, that was my 2 gig of swap space. Oops, it should be an uppercase G. So that's what my disk storage currently looks like. Because I'm going to introduce a problem on the storage. There we go. And what we're doing in this logical volume setup is I'm using a single physical device, that partition devSTA2, and I'm reallocating portions of its space to these additional meta devices. You can see that the device file name is /dev, the volume group name. So my volume group is called RHEL. I took the default partitioning scheme when I installed this machine. It created two logical volumes underneath that volume group, root, which is all the file system stuff, and swap, which was the swap device for this machine. I just installed Linux and took all the defaults for the partition format, and this is kind of what came out. What's really cool about this is that I can store multiple things in the same disk device. The other thing I've got on this machine is I added a second disk device, DevSDB. And I went ahead and created a couple of partitions on it. DevSDB1, which is 5 gigs, DevSDB2, which is 5 gigs, and DevSDB3, which is 10 gigs. And what's really awesome is that with logical volume management, you can actually tie together multiple devices into a single addressable disk space. I can take these different sized partitions or maybe even whole disks and lump them in as physical volumes to our volume group. So we're going to change back over to the terminal. I'm going to show you an example of what this looks like. We're going to go through the process to actually add more space to our volume group and our file systems. And then we'll flip back to the whiteboard and talk about what did we really do with that. All right, in many shows, we've talked about finding big files and figuring out what you can delete to not be disk full. And you'll notice that this machine is currently 100% full on its slash file system. Not where you want to be. In the past, we would try to find what was using the space, but here in logical volume management world, I have this extra disk, dev SDB, and some extra empty partitions on it. So why don't we just add more disk space to our disk and call it good? So what we're going to do is I'm going to just show you what I have here. So I've got three partitions on dev SDB. SDB1 is 5 gig, dev SDB2 is 5 gig, and dev SDB3 is 10 gig. And what I need to do to add this to my volume group is I first need to PV create one of these partitions. So I'm going to PV create dev SDB1. All right, now what this PV create step does is it writes out a little bit of formatting information to this file or to this partition that says that it can now be used in logical volume management. If I look at its PV display, SD, try that again. Well, it let me successfully create it. Let's see if I PVS. Maybe because it's not allocated, it's giving me an error there. So I'm going to do a VG extend. Actually, I just say RHEL. So I want to extend my RHEL volume group to include DevSDB1. Interesting. Man, when your disk is completely full, weird things happen, like you can't do stuff anymore. All right, so let me try this one more time. PV display. Okay. That's what I was looking to do. DevSDB1, because my disk was full, I was having problems writing additional metadata because I filled it up completely with zero free space. Notice that its physical volume size is 5 gig, right? I said it was a 5 gig partition, and it is not currently allocatable. So even though I have that 5 gig there, I can't use it in a volume group setup. So I'm going to do a VG extend on the RHEL volume group to add devsdb1. All right, so now it's successfully extended. If I do a VG display, there's my RHEL volume group. And notice that down here, this has changed. Its current physical volumes, it was one because it only had devsda2 before, and now has two active physical volumes. The other thing to note is this. Before we did this extend, this volume group was 19 gig in size. And so now I've added another 5 gig of disk space, and it's about 24 gig in size. All right, so now I have more addressable space. And let me fill up my file system one more time. Take a moment. We have not tagged this space yet. While that space is available in the volume group, it doesn't belong to either one of these logical volumes that exist, nor have I created an additional logical volume to consume this extra 5 gigs of disk space. I wonder if I'm going to run into the same problem when I try to logical volume extend it. We'll see. I just won't use all the space. How about that? I used 7 gigs of space. Let's see what we got here. DFHP. All right, so we're at 70% usage. That's good. Enough that I can actually use metadata and update files and stuff, but not so much that the machine comes to a crashing halt. All right, so you can see that my file system here is 17 gig in size. That's my root file system. And if I do a LVs, we're looking at this guy. So 17 gigs of disk space. allocated to this logical volume. And then the file system is 17 gigs because it goes over that entire amount of disk space. So I'm going to add this 5 gig that we added to our volume group to this logical volume. I'm going to LV extend plus 5 gig dev rel root. All right, fine. You're rounding, and I don't want you to round, so we're just going to say 1279. There we go. So when you get the math right, it extends. And it added 1,279 extents, which is about 5 gigs of disk space, to my logical volume, right? So if I do an LVS, right, so there it is. I think I added incorrectly. I only added 1.25 gig. So let's do, all right, let's try that. All right, so that looks a little better. I've added about 4.25 gig to this logical volume. And if I do a df-h, notice that while my device is 21.25 gig, the file system is only 17 gig still. So while I allocated more disk space, I didn't resize the file system to consume that extra space. So I'm going to xfs growfs dev rel root, and that resizes my file system to include that space that I just added onto it. And now if I df-h, notice I went from 70% used to 56% used. I also went from 17 gig of total space to 22 gig of total space. There we go. So I've successfully added more disk space to my file system. All right, so let's flip back over to the whiteboard and we'll talk about what we did with all those steps. All right, so this is what we were like in the beginning. I used all of that orange hash marked disk space, right? That was 17 gigs of disk space. I used it all up or used a bunch of it up and I needed more. So we went over to DevSDB, which is a 5 gig device. The first thing we ran on it was PV create. Create. You can see it's a little tiny information into the device. When we did a PV display, it told me what volume group was associated with, what the physical extent size was, whether it's allocatable or not. There was also a space that was blank in there for a UUID number. All that metadata goes in this little tiny little bit of space that goes into the physical volume when we run PV create. So this area is called a volume group descriptor area, or VGDA. It's basically just a spot where we can store information about this device. All right, then we did a VG extend so that this space is now included in my devrel volume group. Right, and what that really did was it cut all this space up into allocatable disk space, which in our tools were described as physical extents. If we look at the text in our terminal, we would see that each one of these little blocks is 4 megabytes of disk space, and that's the allocatable unit inside our volume group. And then what we did was we did an LV extend. So I did an LV extend on dev rel root and added another 4.5 gig of disk space. Now we have disk space able to be stored between both of these physical volumes, these physical devices. And that's why when we added the space together, it was 24 gigs in size now because we added more disk space to it. And then the last thing we did is, even though we had extended our logical volume to account for this space, it had not been formatted with our file system. So if we were to look at the file system data, it said that it was 17 gigs in size. And so we had to use the XFS growfs command to actually push that file system format across all of this space down here, so that we could store files and directories down there because it now has the same file system format as our device on DevSDA. All right, I didn't use up all the free space on DevSDB1. Notice down here there's some unallocated extents. Those are free, and we could allocate them to this file system. We could allocate them to our swap space. We could create a new logical volume out of them and use it to store additional files and directories. We have these two unused partitions. That's our current setup on this machine. Let's flip back to the terminal and take a look at some other changes that have happened on the machine. All right. So early in the episode, we did a VG display, and there was our volume group information. And what has changed is down here, our allocated physical extents. Once we added that second partition of disk space, we got some more free extents. And you can see there's still about 764 megs of unused space. That was that like little sliver at the bottom of my partition. The other thing that's changed is if we do a LV display on dev rel root. So I grew this file system and this logical volume together to take up that additional space. Before, it had been stored in one segment, one contiguous block of extents inside of our volume group. But now it's stored across multiple devices because there are some extents on DevSDA and some extents on DevSDB that are being used to store this logical volume. As you increase the disk space associated with your volume group and span more physical devices, you'll have more of these segments. All right, so let me talk about another thing that we might be interested in doing with logical volume management. Let's say we're interested in phasing out one of our devices that is a component of our volume group. So if we do a PVs, DevSDB1, we don't want to use DevSDB1 anymore. Maybe the disk is too small and we've replaced it with a larger disk. In fact, let's do that. So pv create devsdb vg extend. So we now have 3 active physical volumes. I added that third partition on my second disk, which is 10 gigs. So that's why we went from 23 gigs to 33 gigs. The whole goal of doing this is I want to get rid of that 5 gig partition that I added earlier as a physical volume. There's a command called pvmove. It can be run live while the system is active and the file system is active. And what it's doing is it's looking at each one of those extents in dev SDB1 and copying them to other available extents within my volume group. The space that I have that's available is on dev SDB3. Basically took all the content that was currently in use on dev SDB1 and copied it all into dev SDB3. So if I do a PV display dev SDB3, right? So it's allocated 1088 of those 4 MB blocks of storage. And if I do a PV display on dev SDB1, those 1088 blocks were actually copied from this device, DevSDB1, into the other component devices of our volume group. And now if we look at it, its allocated physical extents is 0. There is no volume group storage currently residing on this device. So now I've moved all the data off, and I can go about removing this device from my volume group and setup. So when we're adding new devices, we did a PV create to put the volume group descriptor area down on the device. Then we did a VG extend to add the device to our volume group. And then we started allocating the space on it. So we want to do the opposite direction now. So we use PV move to take all the existing space and move it to other places. And now we want to do a VG reduce to remove this physical volume from our volume group. All right, so when I look at the volume group after I've removed this device, I should see that it has roughly 5 gig less space. So if I do a LVGS, so we were at 33 gig and now we're down at 29 gig. So that 5 gig of space was removed. If I do a PV display on dev SDB1, right before it was part of the RHEL volume group and it was allocatable, but none of the extents were in use. And now notice that it no longer has a volume group name. It's just out there, not being used by any volume group. None of its space is currently allocatable as physical extents. So I've removed that device from my volume group setup. And now I can retire it, right? So I could do a PV remove dev SDB1. And so this wipes off that logical volume or volume group descriptor area from it. And now I can disconnect this device from my machine and no one will miss it. All right, let's flip back over to the whiteboard and see what did we really do there. All right, to start off with, we PV created dev SDB3. That put down the volume group descriptor area in it. Then we VG extended into dev SDB3, which then added it to our RHEL volume group and divided its disk space up into these allocatable units called physical extents. All right, then we did a PV move. And the PV move took all the space from up here in DevSDB1 and copied it down to DevSDB3. So it looked like this. It went ahead and not storing any logical volume data there anymore. But it was still allocated to our volume group. So we still had these blank allocatable physical extents, but they were unused. And then we did a VG reduce and removed that volume from our volume group. So it wasn't our volume group anymore, but it still had our friendly neighborhood volume group descriptor area there so that we could add it to another volume group or reuse it if we wanted. So then we used PV remove wipe that out. And we were left with just a blank, unallocated partition that I can't draw in our disk layout, right? And let me go ahead and just fix this up here because now our logical volume was instead using 4.5 gigs or whatever it was down here out of DevSDP3 in order to congregate together its 24 gig of disk space. So that's kind of what we did with the um, first PV move to copy all the data to our other replacement disk device. And then we VG reduced it to remove the physical volume from our volume group. And then we did a PV remove to actually remove that volume group descriptor area. Now that PV remove is actually a really critical step because if we forget, it turns out that we've logged the physical volumes that are attached to our machine in some metadata files. And if we disconnect the disk device, the next time we boot the machine and we're trying to reconstitute all of our volume group layout, it'll still look for that device and you'll see some errors appear that it couldn't find a device with that UUID anymore attached to the system. And getting rid of it at that point is kind of a pain. So if you account for it in the future, you're disconnecting the device, you're going to go ahead and remove it and remove its volume group descriptor area so that nothing is ever looking for it again. That's what you want to do is clean up some of this metadata stored about volume groups. All right. So that's moving to a new device or decommissioning a device. So let's take a look at the chat and see what we've got over here in chat. And it looks like it's just a lot of back and forth about using LVM on other file systems. I see that Rick Green said about HP LVM, and it turns out that that implementation of LVM was used as the basis for Linux LVM and the device mapper. Um, yeah, I think that's pretty much what was asked. All right, should we create another volume group or a logical volume group? All right, so I've got all this space. If I look at VG display, I've got some extra space, about 5 gig of free space. So we can also create new file systems and new devices using this free volume group space. So I can do a LV create. I have to give it a name. I'm going to give it a very uninventive name of data. And we have to tell it how much to allocate. So we're going to do 4 gig. All right. So it created a logical volume called data within the RHEL volume group. If we look at a VG display, we can see that we now have 3 logical volumes created. Only 2 of them are active because we haven't used this one yet. Our free physical extent or free space went down because I allocated a bunch to this logical volume. I grabbed a bunch of those physical extents, isolated them together, and assigned a device file to them. But right now it's just raw, unformatted disk space. So the other thing I'm going to do is I'm going to make a file system of it. So I made it a XFS file system, and now it's got a correct format. And let's go ahead and mount it. So I created a mount point called /data, and I mounted it. If we look at df-h, there it is. Roughly 4 gig, which is what I told to create. We formatted it. Now I can put files in it. All right, so let's go over to Whiteboard. What did I just do? All right, What I did was I went out and I grabbed 4 gigs of this unassigned physical extents that were part of this volume group. Right, so I allocated all this space, and there's a little bit left. See down there at the bottom, there's a little sliver left of unused space that's still available to the volume group. Then what I did when I created that LV create command is I said I wanted 4 gigs of space, and I also gave it a name. And that name created dev volume group name, the name that I supplied in my LV create. And then I formatted this space as an XFS file system and I mounted it, right? So that's what I just did with that LV create and the format and the mount was allocated this to space, formatted it, and then attached it to my machine so I could store files in this little segment of disk space. All right, so that's a little bit on logical volume management. I think that the key things to be aware of is there's the 3 layers, right? There's the physical layer. What devices are making up your logical volume management infrastructure? There's the volume group layer, where you're taking devices and you're tying them together into a meta device called a volume group, and that can span physical devices. The third thing is you make a logical volume. A logical volume is how you claim portions of that volume group space to store file systems or other stuff. So that's where we did the LV extend to grow one that exists to grab onto more space, or the LV create to make a new logical volume to grab that disk space that's part of our volume group. We had to work with the file system format. Just because you add disk space doesn't mean it's formatted. So we had to use tools like XFS GrowFS to push that file system into our newly allocated space to our existing logical volume and file system space, or we had to use MKFS to take a new file system and lay it down on this newly allocated logical volume that we created just a minute ago with data. The things to keep aware of on this is what devices are components of your volume group, right? So what physical devices are components? And we talked about how if you need to retire a disk, you can move all the in-use stuff off of it using pvmove and remove it from the volume group and wipe out the volume group descriptor area so that you can remove it from your system. The key thing there is that each one of the components in your volume group has a unique ID, a UUID assigned to it. And that UUID for each component is tracked in a bunch of configuration data. If you disconnect those things from your machine, but the configuration data still exists, you'll end up at boot time getting a bunch of error messages about not being able to find these component devices that the system expected to be there but are no longer there. So that's why we use commands like pv remove to delete that from our configuration metadata so that we could completely disconnect the device and not have any leftover data associated with it. Just be aware of those types of things when you're working with logical volumes. Realize that you're building this kind of amalgamation of different devices that you're then going to store files and directories on. All right, one other question I get asked a lot. Because we're creating this meta device of other component devices, and even a meta device of that with physical extents, trying to figure out what portions of those different devices we're actually storing data on. People often ask me, is Logical Volume Manager slower than straight disk partitions? And on the surface, like if we look at the extra work that's being done, yes, we have to look at the metadata that's there and figure out where we're storing things in physical extent sizes. We're doing file system operations. So there is more overhead in doing all of these disk device things. Intellectually, we know that it's more challenging and takes more compute time to do. But the reality is, it's not perceivable to processes or people. So What we gain with logical volume management is all this extra flexibility of being able to slap devices on after the fact and grow our file systems and then shrink stuff and move our disks around to other places. We get all that flexibility. Reduction of service goes true for things like benchmarking too. Benchmarking really doesn't show any perceivable degradation of service going onto partition formatted file systems versus logical volume managed file systems. You gain flexibility. Intellectually, we know that there's more work being done there by the kernel and the system, but practically, it's imperceivable to us and our processes. I wouldn't worry about that and would instead enjoy the flexibility that LVM provides you. Hey everyone, let's jump into the terminal and we'll take a look at what we're going to be using today to help us out. A few applications are quite as ubiquitous as our friend ping. That's going to be one of the key ones for troubleshooting network issues today. Ping takes a host name or IP address as an argument and will send ICMP packets to that host, and then that host responds with a echo packet back. So what we're being told there in the output is the size of the packet that was sent, where it was sent, and the response that we got back. We're given the sequence so that if we are having intermittent network issues where they're dropping packets somewhere in the network, we would see the sequence be skipped to tell us that we're missing pieces. Time to live is how many hops it can do. And then the time is the round trip time between this computer and the target computer and back again. Basically, the latency. How long is it taking for this ICMP echo to be received ICMP packet to be received and the echo sent back to us. So pretty quick, right? 8.4 milliseconds, 16 milliseconds. That's quite good. I have been in places where it's been like 500 milliseconds, which is not great and indicates there's a lot of latency on your line. Another tool, TracePath. The TracePath sends a series of UDP datagram packets that sets the time to live on the packet to be incrementally larger every time it sends out a packet. It sends out a series of them. And when the recipient receives the datagram packet and sees that it has exceeded its time to live, it sends back an error response, which is how we identify who received our packet. So we could see that it was received by my local system. Then it went to our default gateway. And then it went to a machine called security gateway. Then it went to my internet router. And then it went to somewhere in my internet service provider's network. And then it bounced around to a couple of IP addresses. And it still continued to bounce around. Now you'll notice that there's a bunch that say no reply. Network devices can be configured such that when they receive an expired packet, they don't send that error response back. TracePath will send 3 packets to a recipient. If it doesn't get any response to those 3 packets, that's what you get with the no reply. And then it tries to go to the next hop. So it is possible that the no replies they've just turned off error messaging, or it could be that something's happened and we're not getting responses past this location. By default, TracePath will send out 30 hops of data. So if between yourself and the recipient getting those packets is more than 30 hops, you may need to use a command line argument to make it so that your packets there's more series of packets sent out than the default, which is 30. There is another application called TraceRoute, which is a little bit older application. So TracePath is kind of the new one. But we can also use TraceRoute. And TraceRoute kind of does the same thing, where it sends out a series of ICMP packets by default. This is the same type of packet that a ping sends. I'm going to send out with a time to live so that at some point someone's going to receive an expired one and it's going to send back an error message that helps me identify who that person was. The other thing with TraceRoute is you can use the capital T option to, instead of sending out ICMP packets, you will send out TCP formatted packets. Systems can be configured to not send back data when they receive error stuff. Well, that's true for different protocols as well. Someone can choose to configure their machine to not respond to ICMP packets, but would respond to TCP packets. You can also do with both TracePath and TraceRoute port connections so that you're not just checking to see whether you can get a packet to this host, but you can actually check to see whether you're getting a packet to the host to a specific port number and service on that host. All right, our next application for our network troubleshooting, Dig. So Dig is a DNS lookup tool. There are several others as well, like Host or NS Lookup, that are more traditional. I like using Dig because Dig actually gives me the full DNS record that goes with the DNS lookup. So, for example, if I just did a host google.com, right, it comes back with the name and the IP addresses. Whereas if we look at the Dig output, it gives me the time to live information. So these records will live in any cached DNS server for 53 seconds. It also gives me the type of record. So an A record tells me this is name to address association, but there are other types of DNS records too. We could come across a CNAME record, which is like a DNS name alias. And Dig would tell us that it's a CNAME record, whereas the other tools don't necessarily give us that context. The other thing that I like with Dig, and NS Lookup also does this, is it tells me the server that it asked the question to. So down here in the tail, it tells me where my request for DNS lookup went. So I know that the data passed back through that server. And that might be important for doing things like troubleshooting DNS server settings or something along those lines. So I like Dig as my DNS troubleshooting tool. All right, then we start to look at some other more local system settings tools. For example, we have IP. IP is the like everything you ever wanted to know about your networking utility. There are several subcommands with IP that give you specific things. For example, IPA shows you your configured IP addresses. So we have the loopback interface, this is 127.0.0.1. We have an IPv6 loopback interfaces as well. My network interface ENP0S3 has two IPv4 addresses assigned to it, as well as an IPv6 address assigned to it. We also have IPR. IPR shows you the routing configuration of this machine. So we can see that the default route on this machine is configured to send packets to the IP address 10.0.2.2. We have our two IP addresses assigned to this machine. So for 10.0.2.0 network, we're directly connected, meaning we don't have to use the default route. We're also directly connected to a network called 192.168.10 dot. That also would be direct transmission rather than sending data through the default route. For me, this is a little bit more difficult to read. I like the tabular output of route. This is the same information as IPR, or a lot of the same information as IPR. The big difference is that it is more tabularly formatted with route output as opposed to IP. The other thing I did was I threw in the -n option, which says, show me only numbers. If I don't use -n, it would try to do DNS lookups for things like the default gateway's IP address. A lot of the commands that we use have behavior that does one thing for IP address arguments and something slightly different for a host name argument. All right. The last command that I'm going to show you is also a very large one. So that is NMCLI. Now, NMCLI is the Network Manager command line interface. Network Manager is how networking is managed on Red Hat distributions, which is what I'm using, CentOS Stream, as well as Fedora. They all use Network Manager as the application that controls their network settings and at boot time takes care of configuring the network interfaces. So NMCLI also has a hook into bash completion. So what I did was I typed NMCLI, hit tab and tab again, and it says, here's the next argument that you can pass to NMCLI. So I could do an NMCLI connection tab. And if I hit tab one more time, it'll say, okay, if you're going to do NMCLI connection, here's the next argument you can use. So I could do something like show, and it'll show me the connections that are active on the machine. I can also do something like NMCLI connection, tab, and these are the things I can offer. So maybe EMP0S3, and it goes into that specific connection and then shows me all the parameters that are affiliated with that connection. For example, I can search in here for IPv4, and these are the IPv4 settings that are applied to this network connection. And so we can see things like the IPv4 addresses. So I have a statically configured IP address 192.168.10.222. And then it turns out my other one is assigned via DHCP. There's also a variety of settings for IPv6. And if I keep scrolling down, this is probably one of the nice things. I said my other address was configured via DHCP. Towards the bottom of the NMCLI connection show and the name, it'll show me the DHCP lease information that was received for any DHCP configured addresses. So 10.0.2.15 was the IP address that my DHCP connection was assigned. 10.0.2.2 was the default gateway IP that came with that lease. 192.168.1.1, that was the DNS server configuration that was provided as part of that lease. And so you can see all of the different DHCP lease parameters that were provided with those interfaces that were configured via DHCP using NMCLI, connection, show, and then the connection name that you want to display. Right, so this NMCLI connection show and then the name gives you all that detailed information. You would also use NMCLI to change any of these parameters. So when I added that secondary IP address of 192.168.10.222, I used NMCLI to apply that change. And it gets stored in a backend database that NMCLI stores network settings in, so that when I reboot the machine, changes that I make using NMCLI will persist between reboots on the machine. All right. So those are the tools that we're going to use today. Ping, TracePath, dig, IP, maybe route, and NMCLI. Let's jump onto the whiteboard here and let me put together some really terrible artwork that you all can make fun of me for. There's my computer. And there is a network address, which is 10.0.2.15. So that's what we saw during the critical path when I ran IPA. It showed me my configured IP addresses. We also saw it in the NMCLI output. That's how my computer is connected to the network. There may be other computers connected to this network that I can directly talk to on my subnet. But there's also a default gateway connected to this network. And its IP address is what we saw in the route command and IPR commands, which is 10.0.2.2. Oops. All right, so when my computer wants to send something to a computer outside of this network, the 10.0.2 network, it has to route that traffic to the default gateway. The default gateway has another IP address or another interface that goes somewhere else. which may be more of my corporate network or internet service provider's network. It may be direct out to the internet, depending on your configuration of your network and how you manage it. All right, but then on the other side of the internet, there's another computer. These were two that we used during the critical path. Both of these are configured to respond to ICMP echoes, right? To pings that are sent to them. When we were looking at the TracePath output or the TraceRoute output, what we were really looking at was what was happening in the network and internet fluffy cloud. We were seeing our packet left our machine, hit our default gateway, then went through our local network infrastructure to our internet service provider, then out to other routers on the internet, and then eventually would land on whatever this target host was. And then packets would come back to us. So TraceRoute and TracePath are helpful for seeing what stops your packets take on their way to get somewhere. Your DNS server is also out here somewhere. On my machine, it has the IP address 192.168.1.1. So that's a non-routable IP. I know it has to reside within my local network somewhere, but we could use a internet connected DNS server as well. And so what happens is when I use a command like ping, and I give it a host name, or I use TracePath and I give it a host name. The first thing we need to do is figure out what the IP address on the internet is, or the local network is, of that host name. And so before it does anything, it'll actually kick off a DNS request. Behind the scenes, to then figure out what IP address goes with this host name. And there's a variety of things that happen there. The first thing we do in the DNS lookup is we actually look at a flat file. This is how most machines are configured. We'll look to see if there's a DNS entry in Etsy hosts, which is a flat configuration file that resides on your local machine where you can tie specific IPs to specific host names. If it's not in there, then it'll check some other network services that most people don't use anymore. If it's not in one of those, it'll then do a DNS inquiry to figure out what IP address goes with this host name. A file called etsyresolve.conf. And that's where our DNS server specifications are for this machine. But basically, it says these are the machines you should query for DNS lookups. And on my machine, the only one that's listed in there is that DNS server on my little terrible diagram, which is 192.168.1.1. So once we get the IP address that goes with that thing, then ping will actually go to whatever the IP address is that it looked up. Let me do a quick look here. All right, so maybe it's 140, whoops, 142.250.105.104. And that's where it'll actually send the traffic, right? Who it looked up with DNS. But because you provided a host name as your argument, when it provides you the receipt of those packets, it'll resubstitute the host name in its output. So you ping www.google.com, you'll get back a response that www.google.com responded to you and some metrics on round trip time and other stuff. DNS is pretty seamlessly integrated in all of our things, and it happens behind the scenes, and most people don't pay attention to it, which is great until it doesn't function properly. So When we do this ping, it does a DNS lookup first, figures out the IP address that needs to go with it, then takes that traffic, it will assign it to the network packet that needs to be sent. Because it's not for our locally connected network, it then goes to our default gateway. Our default gateway will then route it to the internet. The internet routers will bounce it around until it goes to Google, who then responds back, which then gets delivered to our default gateway, which then makes its way back to us, right? So that's the flow of things. If we use a host name, we will first use our network settings. It will be from here to here, out to our DNS server and back again to do our DNS lookup. Then it will go from our computer to our default gateway, bounce around out on the internet to our target host, and then traverse back. That's the way normal networking things happen. All right. So let's turn off the whiteboard, and then we're going to go back to our computer and see what happens when things go awry. All right. So we can pull back up, and now this machine is not functioning properly. And we can see that because when I do things like ping, it's not giving me that 64 byte packet round trip time that we were getting before. And this actually is affecting all my tools. If I do a trace path, nothing. Notice that for each of those tools, I was passing a host name as the argument. When I'm troubleshooting a network problem, I want to keep things as simple as possible. We know that if we use a host name as an argument, we add a complication into how we're passing network traffic around. That complication is we need to first do a DNS lookup on the host name before we can do anything else. So, what we're going to do to decide whether that complication is causing our problem or not, we're going to run the same two tools, but remove a host name and replace it with an IP address. So, ping by IP address is working just fine. TracePath with an IP address is kind of working. Maybe we need dash n. There we go. The reason it kind of stopped was because it was trying to do a DNS lookup on all the machines that we connected to then show me the host name in the trace path output. So -n says, give me just the numbers. Don't worry about DNS lookups. So now I'm seeing the IP addresses of all of the machines that I'm connecting to send this packet on its way to 4.2.2. So my symptoms are using host names doesn't work. When host names are trying to be resolved, like I do something like dig. But when I use IP addresses, that seems to be functioning fine. These are the hallmarks of a DNS problem. There's a famous internet haiku about DNS. It's not DNS, it can't be DNS, it was DNS. So, because DNS is kind of ubiquitous and involved in all of these things, like we saw TracePath just kind of froze, even though I had passed an IP address because it was trying to do DNS lookups on those return IP addresses to figure out and display more human friendly output. So, it'll manifest itself in weird ways. But the way that we troubleshoot it is we use tools like ping, or we use arguments like -n that turns off DNS lookups for tools so that we can see whether it's an IP layer thing, a networking layer thing, or a DNS thing. All right. I told you earlier that etsyresolve.conf is the place where my DNS servers are listed. Here's my DNS server. One of the things I can do is use a different one. So I could put in here name server and somebody else's name. 4.2.2 is a internet provided name server. And now we can do things like ping www.google. And things are working again, kind of. So that tells me again that this is reinforcing that I have a DNS server problem. I don't like to use someone else's DNS. The whole reason that we have DNS internally is so that we can have our own internal network namespaces that we use for machines and a variety of other things. So if we don't use our internal DNS at all and we use someone else's DNS, that's probably not going to be good long term. So let's figure out what's going on with our DNS server. All right, so let me delete the other one. So we're now just using that one that was in there. So we could do things like ping it. And it's not responding to pings. So it looks like the reason that we're having DNS problems with the server is because it's not attached to the network or my network routing doesn't get me to it, which would explain why it's not functioning properly. But there's something else. Often what I find is it's actually not the server on the other side of our DNS queries that's the problem. Often it's our own local configuration that's the problem. And that's what's happening here. So if we take a look at the NMCLI connection data for our internet, for our IPv4 address, right, we're going to look at the connection details for ENP0S3. At the very bottom, you get a list of all the DHCP provided data. And what I want to draw your attention to is that line right there. So when I got a DHCP lease, it said, here is your DNS server. And that gets populated into our etcresolve.conf file. But if I look at my resolve.conf file, that's not the IP address that's in there. And you may have noticed that there's a comment in this resolve.conf file which says, this file is generated by Network Manager, which means don't manually change it. And somehow the name server entity was changed to not match what was provided by our DHCP lease. So I'm going to go in and manually change it back. So now it matches the DNS server that was provided to me as part of my DHCP lease on this interface. And now if I do a dig, which we know is a DNS lookup tool, it's working. The problem was that our DNS server was misconfigured. The local connection to whatever DNS service provider is out there that we're supposed to use was incorrect. And because we were routing packets to another machine that wasn't a DNS server, we weren't able to perform any of those DNS lookup activities. All right, so how does this happen? One is just like what we saw here. Somebody goes into the file and changes it. Very common. They put the wrong data in it. In my experience, that's been one of the most common reasons why this problem happens. Something else that could happen is maybe we have multiple interfaces and the DNS provider for another interface gets put in on top of our preferred one. Another common resolve.conf problem that I'll see is where you may have more than one name server specified, but the wrong one is listed higher in the file. And what will happen is it will cause DNS lookups to be very slow. Notice that it worked eventually. It's kind of working, but super slow. That's because having the wrong DNS server in our file higher up, they're queried in order. And so we're trying to hit that one that doesn't exist. We have to wait for it to time out. And then it goes to the second one on the list, which does exist and provides the right response. When we get our ping response back from that machine, we have to resubstitute its IP address for a host name. So we again do a DNS query, which we have to wait for that top server to time out before we can get to the active DNS server. So DNS server settings is one of the more common causes of network problems. You can troubleshoot it by using IP addresses to verify connectivity at the IP level. If you have success there, but not success with host names, then that will direct your search to like, what is the correct DNS server I should be using on this machine? Are those settings reflected in the configuration files like etcresult.conf that I'm supposed to be using? Or is this incorrectly referenced in my maybe something like my network manager configuration for this interface? So you can start to look at your settings and where they should be applied. All right, so let's take a moment and look at the chat here. I don't really see any questions on the chat. I see TTY Bitnik says, indeed, I had this problem in some container images. It's always worth checking. So yeah, containers have their own network settings, which means that they have their own resolver and they may send packets in a different way than the host operating system. All right, so let's flip to the whiteboard and we could see what was going on with that problem. All right, so this is where we left off on the whiteboard. I said that when we're using host names like www.google.com, we had to do this top yellow path of doing a DNS lookup to figure out what that IP address is. We put the IP address in our network packets to get them to the destination. But the problem was that when we were looking at that yellow, it was following this first hop and it was going out to the network, but instead it was being routed to this incorrect host name that didn't exist. It didn't provide DNS services. And so that connection would time out, and then we would just kind of see emptiness when we were using DNS queries. When we put it in so that the incorrect server was listed first, we'd wait for that timeout to occur, and then we'd do the DNS query against our actual DNS server that was also listed as a secondary in our etcresult.conf. So we got the resolutions, they just happened really slowly because we had to wait for that first server to time out for every single DNS query our machine did. All right, so uh, I'll have to draw again. So let me break my machine in another way, and we'll take a look at another network problem. 1 second. Producer, yeah, here we go. Because I want to break it in a way that not everyone sees immediately because they watched me break it. All right. So let's bring up the host because now it's broken and not working the way we want. So let's try our troubleshooting, right? Ping a host that should be up and responsive. Nope, not working very well. Okay, but we know that because we're using a host name, it could be a DNS problem. So let's also ping by IP address. No responses, right? Destination host unreachable. Woof, that's rough. This looks like a real problem. So let me see what else we have going on here. First, we're going to see if our IP addresses are configured. All right, so we have two IP addresses on ENP0S3, 192.168.10.222, and 10.0.2.15. If I connect to it, I should try to connect to another machine on my local area segment. So like ping 10.0.2.2. That's on my local area segment, and that's working. Cool. My network interface is able to pass packets to another machine on my network. But let's try our DNS server. Destination host unreachable. Traffic is able to pass to my local machines connected to my local area segment, but they're not able to be sent to machines outside my local area segment. So you recall when we started talking about the correct flow of traffic to different machines on the network, that if I'm sending something to my local area segment, it's just put on the interface and sent. But if I'm trying to send something outside of my local area segment, it goes to a specially designated machine called the gateway. The gateway is connected to other networks and up into the internet to route the traffic to wherever that end host is going to be. My problem is manifesting as local area segment works fine. Anything on the other side of that gateway, not fine. So that would lead me to start looking at gateway things. So you saw me ping one of the machines, 10.0.2.2. That's fine. But if I try to ping outside again, we're getting this host unreachable error message. Notice who this error message is from. So in our earlier things where we were passing traffic back and forth or watching things like TracePath, all the traffic was routed to a gateway called 10.0.2.2. But now when I'm doing things outside my network, I'm getting error messages from a different IP address, 192.168.10.222, which is one of my configured IPs, but that's not the one that was routing traffic out to the network earlier. So we know a couple of other commands, another couple tools that we have in our toolbox. We could do something like an IPR, or the one I like more is route-n. This is what my machine's routing table looks like. If traffic is destined for the 10.0.2 network, that is a directly attached network to this machine. No gateway is required, right? 0.0.0.0.0, no gateway is required. If I am sending traffic to 192.168.10 dot network, no gateway is required. But those are my only two directly connected networks. So anything outside of those, if I send traffic, it's going to have to go to my default gateway. And here's where the weirdness happens. I have two default gateways. So this 000 for the destination means all destinations. And then the gateway is the IP address of the router that should receive that traffic to pass it off to the next side of the network or internet. And I have two of them. So if I have two of them, which one gets used? And it turns out the first one listed is the one that gets used. So in effect, even though I have multiple default gateways defined, only one is actually used, and it's the topmost one in my routing table, which is this one. So here's my problem. When I'm putting together packets to send outside of our network, they're being sent to a machine called 192.168.10.1. And that machine doesn't exist. Or maybe it's not routing things properly. But for whatever reason, traffic is not passing through that IP address or the machine connected to that IP address. So here's what I'm going to do. I'm going to do a route del to delete that route from my routing table. So now I've gone back to only having one default route. And now all of a sudden, things start working the way I expect. And if we do things with DNS names, everything is operating the way I would expect. Because now, thanks to my routing table, If I'm sending traffic to one of my two directly connected networks, we just put it on the interface and it goes on its way. But for anything else that's not addressed to one of my locally connected networks, it goes to this machine 10.0.2.2, who receives it and then figures out how to pass it down the line. The problem was that I had a bogus or non-functioning gateway in my configuration, and it was listed first, which meant that was the default route that my machine always passed traffic to. As soon as it got there, it just kind of died because it wasn't being passed to the next hop in the chain. All right, so how does this happen? Well, in my case, I actually manually added the bogus route, and that's why it was added in there. But I've also seen this happen when you have multiple network interfaces configured on a machine. One of the properties that we set with network interfaces is the gateway that goes along with it. If I take a look at NMCLI, connection show EMP0S3, and I look for gateways, I don't see any configured, except down here, it was a part of my DHCP lease. So that's how I got that correctly functioning route. But what if I had two network cards? Each of them was provided a default gateway as part of its DHCP lease, or each of them had a configured gateway as part of their statically defined settings. Well, in that case, whichever one is activated second would actually be the preferred route. And so you start to get into some weird stuff when you have multiple gateways defined for each of your connected interfaces, where whichever one is activated last becomes the default route. And if that route is not working properly or is incorrectly defined, all of a sudden traffic gets weird. The other thing is when we started to route traffic with that other address, it actually started routing through a different interface, which could be connected to a different VLAN in our local network and could have different rules assigned to it. Default gateway defined in your configuration is going to make your life much easier. With things like DHCP, but if you're defining your secondary interfaces with static networking, defining the gateway is one of those settings that you can define in your static networking. I would recommend having one default gateway for the machine, not more than one. And if you do have more than one, realize that whichever one is at the top of that routing table, that's your actual default gateway, regardless of how many others are defined. Now, there are some difficult network settings that you can put into place that will have a bunch of group routing rules where you can utilize more than one, but that's pretty uncommon to see. And in fact, what I just showed you is the more common problem, which is you have more than one default gateway and the wrong one gets used by accident. So that's how to troubleshoot routing problems. All right, I wanted to talk about one last thing before we're finished. Earlier, we're talking about the different tools that we have at our disposal. For each tool, I said, this is the protocol it uses, right? Pings use ICMP traffic, TracePath, UDP traffic, TraceRoute, ICMP, or TCP traffic. And that is important because it turns out administrators can set things on their machine that will cause them to behave differently. If we bring up the machine, if someone were to try to ping this machine now, it wouldn't work. Oops, sorry, wrong one. Ping 127.0.0.1. Somebody tries to ping its IPv4 addresses, it won't work. Because as the administrator, I have turned off ICMP protocol echoes. So my machine will receive an ICMP packet, and instead of sending an echo response, I'm throwing that packet away. That's going to affect things like trace routes as well. The trace route will by default send ICMP traffic, and this machine throws it away. We can see that this machine has a 100% packet loss, but its networking is working fine, right? We can connect to services running on this machine. If somebody were trying to connect to this machine via the web service, it would provide web pages. Or in our case here, you can see it's providing SSH services to an SSH connection. But if someone were to ping it to see if it was alive, nope, would not respond. And whoever is actually trying to ping it might assume that the machine is non functional. The actual setting that changed is a kernel setting. So this setting is defined in the Linux kernel, and I flipped this to a 1, meaning I am now ignoring all ICMP echo requests. Normally, I would send an echo to say, yes, I've received your packet, but now not responding at all. The default for this file is 0, meaning you will respond to ICMP traffic. The reason it worked when I just typed in the word localhost is because there's also one of these for IPv6 interfaces, and I didn't manipulate that one. So when I did a ping localhost, it was responding back from its IPv6 address, colon, colon, 1. So if you're manipulating this, you need to remember to do it in both places. But that's why it's important to know what type of protocol your diagnostic tools use. Maybe ping's not working, so I should use TracePath, which uses UDP traffic. Or maybe I should use TracePath with a port number to see if I can connect to a service running on that port number rather than relying on something like ICMP echoes, which the administrator can turn off. Or maybe I want to use TraceRoute and connect to a TCP service because not every machine will allow UDP connections. Web services by default don't do UDP connections, but they will do TCP connections. Knowing the network protocol that your service uses is important because that can help shape your data to know what's happening on the machine. So that was my last word of warning of is know ICMP, UDP, and TCP and what those mean and the tools that use them. And I see that Fernando very rightly saw that I had configured my machine to discard ICMP echoes. That's actually a common thing, and you'll notice early in the segment, I was using TracePath and we're getting no replies. That's what's happening there. We're getting no reply from the machine that got that expired packet because there's been a configuration to not respond to the expired packets. A lot of the times when you're troubleshooting boot, we'll actually go through a whiteboard of what a good boot or what the process of boot looks like. A lot of times, what I found is there's file system problems, and that's what causes you to have problems booting. And so I know that we covered file system troubleshooting in episode 111 and 112, but we're going to be using some of those tools again today. So they're disk free and disk full, as well as where they're mounted. The last thing is the ones to look at our block devices. So fdisk-l will list the file systems on your attached devices. And then we also have things like lsblock, lsblk, list your block devices in a tree format, and blkid will show you your block IDs of the different block devices that are being used for your system. So we've covered these in the past, so this is a real quick run through. The new commands that we're going to use today, we're going to use fsck. fsck is file system check. You probably want the file system to be unmounted when you run it, but we could do something like,
I don't always check my file systems, but when I do, they're live.
so it actually complains that you can't do it live. Let me unmount this guy and try it again. It checks the file system state If it's a dirty state, meaning it was not unmounted cleanly, it can do additional things like verify the consistency of the file system. It'll look at the inode tables and see if there are any files that look like they were incorrectly removed from the system and may be able to recover them, which is actually why we have the lost and found directory in the top level of our file system devices. All right, Nate, why don't we pass it over to you and you'll take a look. I have one more. Grub install. The bootloader is really important when booting the system. So grub install, grub2 install. And we got to tell it what disk.
Yep.
This will take our grub configuration file that is in boot and translate it into a master boot record or EUFI BIOS stored boot record. We'll talk a little bit about how that works when we go through the boot process, but grub install will forcibly install a new configuration for your machine for booting.
It also puts some machine-specific files into /boot, which I discovered while preparing for my later demo.
I can't wait to see it.
So our next tool related to boot is Journalctl. Now, Scott and I went back and forth on this tool because there used to be a tool called MK-initRD. Journalctl does what MK-initRD used to do, which is to make a new init RAM disk, which I'm sure you're going to talk about in your whiteboarding session, Scott. And then the last thing I wanted to talk about was rescue mode. We also have a knowledge base article about how to use Journalctl. I don't have a demo for it prepared. And to be honest, the knowledge base article covers it pretty well. So I don't know if the next thing I wanted to talk about was rescue mode, which I am going to use quite a bit today. There's two ways to get into rescue mode. And my demo is going to show you how to get into one of them. And my demo later is going to use the other one. I've got a booted RHEL 9.4 system right here. You can see. Sorry if the font size is a little small. It's hard to do in these virtual consoles, but we're just going to reboot it. Right, so reboot. And what you'll see is in the console, when you get to grub, there's these two boot items, right? The first one in the list here is, of course, the default boot target. That'll boot your normal RHEL system. And then this rescue system is meant to be a stripped down boot entry that is separate from your normal OS boot entry, which can save you in some circumstances, depending on what sort of failure you're hitting. So if I hit that, it'll boot into a system that feels very much like my live system. It might skip some drivers, but the important thing is that it's a different boot entry. So if you somehow hosed up your primary boot entry, you can go to the rescue boot entry to get the system booted and fix whatever you broke. So, and then the other way to do it is to boot off a live CD. Sorry, go ahead, Scott.
So the reason that this booted up is it didn't have any problems. It used the rescue kernel, but all the other parts of the boot procedure were working just fine, which is why you got to this console and you can log back into the machine. But if you are having problems booting the machine, it'll actually fail. And we will do several of these today where it dies in the middle of booting. But what's unique about rescue is that the initial RAM disk image that comes with the rescue kernel has a whole bunch of tools and applications in it to help you troubleshoot and repair those problems. So even though it'll crash out kind of in the middle of the boot, the initial RAM disk image provides you a bunch of applications to help troubleshoot and repair the problem that would not normally be in the initial RAM disk image for a normal system.
I found that on a number of different ways to install RHEL, like if I built an image using Image Builder, that rescue kernel isn't listed. So I don't know if there's an option you can turn it back on. Maybe that's because it's designed for cloud deployments where, you generally won't be able to boot to a rescue mode. But if you install from the RHEL install media, you get it. So just something to keep in mind.
And that changed, I think, in Red Hat Enterprise Linux 8. I don't recall it being there in 7.
I don't remember when it changed. I expected it to be there and it was not.
Yeah, it was
because I usually build these from an image builder and I had to go and install them manually to get the system I was expecting to have for my troubleshooting.
Right on.
All right, so yeah, that's rescue mode. The other way to get into rescue mode is to boot from the RHEL installation media and tell it to rescue an installed system. And I'll show you all about that in my demo later.
All right, so that's our toolbox today. A bunch of file system utilities. FSCK is new to us because it's going to help maybe repair a broken file system. grub2 install to install a new configuration into the boot record of your system. Dracket, we didn't really talk a lot about Dracket, but usually you would use it to create an initial RAM disk image when for some reason the initial RAM disk image that gets created by default doesn't include something you need unique to your system. So maybe there's a device that you need the driver for at boot time. You can't wait until after the machine boots and we load it as a kmod later off the file system. So things like HBA card drivers because we stored files on them, as an example. Rescue mode gives you this in-RAM recovery environment that hopefully you can use to recover your machine when things are really bad. All right. So the other thing that's kind of unique about our troubleshooting episodes is we talk about what does normal look like? Because if you don't know what normal looks like, how do you know where things are failing to then focus your troubleshooting efforts? So why don't we flip over to the whiteboard and we'll talk about what happens at boot time. Please bear with me as my art is horribad and no one pays me for my fantastic whiteboarding. The first thing that happens in your boot process is your hardware initializes. Your hardware boots up and you get the vendor splash screen and it's doing its power on self test. And that's independent of Linux, right? That's with the hardware provider. One of the things that's going to happen from that it's going to figure out its boot device. And that's actually set in either the EUFI settings or your BIOS settings. And so you can change the boot device or it'll scan maybe a list of boot devices to figure out which one to use. Normally, whichever boot device it encounters first on that list is the one that's used, which is why you might need to reorder or choose a temporary boot device to force it to do something like boot off the Red Hat install media to get you into the rescue mode off the install media. So your boot device is selected. And normally, that boot device would be something like a hard disk. So your boot device is selected. If it's a hard disk, it probably has a bootloader stored on it. Now, how this bootloader is actually stored is a little bit different between a classic BIOS and EUFI. I won't go into the tedious details between the two of them, but essentially, in both cases, there will be a bootloader that gets executed on your boot device. And for us, Nate, what bootloader do we use?
We use grub2, which is why there was a grub2 in that command.
So a while back, Red Hat Enterprise Linux and Fedora and all the Red Hat flavor distros moved from Grub 1 to Grub 2. Grub 2 has a small executable stored uh, at the beginning of the disk, which is what gets run by your BIOS or EUFI boot. And so we call that stage one. It's shocking that's its name. But stage one has enough
Shouldn't
stuff
it start
in
at
it.
0? What the heck?
Stage one has enough stuff to be able to load or read a configuration so it knows what different things are on our boot devices and it can access stage two, which lives in the slash boot directory. And it knows where stage two is because it has the block address of where that executable lives stored in its stage one configuration. It goes into the boot file system and just executes stuff off the disk without mounting or using the file system. That's one of the reasons why historically boot has been its own file system, its own standalone partition, is because in the olden times we had problems with things like being able to access those blocks beyond a certain place on the disk directly. A lot of those have been lifted, but we still kind of operate in the same way. All right, so grub, we execute stage one, which will then execute grub stage two off the disk. And grub stage two is what interprets the configuration for it, right? So this will prepare your menu. Now you get to choose your list. There's a timer by default of 5 seconds where you can interact with it to change what kernel you're booting. But in that configuration is a couple of things. One is the kernel that goes with each entry. So when I pick this entry, there's a file in the boot directory that corresponds with that entry. And we're going to access that file and load it into memory as our kernel. So we choose our boot target, which is going to be a kernel. Man, and RAM disk. So there's two things that are in there. The name of the kernel file we should access and load into memory, and the name of the RAM disk file that goes along with it that we should access and load into memory. So those things get uncompressed into memory and they'll be initialized, and then you'll start seeing a bunch of kernel messages on the screen. After that, we launch process ID number one. Nate, what is currently process ID number one?
Now you're quizzing me here. Process ID number 1 is systemd or init. It would have been init. No, what are you writing there?
So what happens is the kernel, as part of this boot, is going to access the slash file system read-only. Once it can access it read-only, it's going to execute the systemd process. And like a gajillion years ago, that was the init daemon, but now it is systemd.
Unless you're not running systemd.
Yeah, there's like Linux distros that don't use systemd these days, right? Maybe if you're one of them, you're still using init.d. Systemd is executed, and then systemd looks at its configuration to figure out the default target it should boot to. For the systems we're looking at today, that's probably multi-user target. That's what it's using. I, of course, am using
The
graphical.
wrong one. Yeah.
Yeah, because I believe in servers with GUIs and not everyone does, and that's fine. So it's going to pick the default target. There's others too, but multi-user and graphical target are the most commonly used. All right, based off of that target setting, it's going to get the machine fully booted. So it's going to be
Right.
enabling services. It's going to be mounting all of the file systems out of the etc tab file. It will also remount the slash file system read write, and it assembles your working system. And then at the very end, it starts up the console for you to log into. In the case of graphical target, it'll be the graphical login screen. In the case of multi-user target, it'll be one of the TTYs that sit there at the text console so that you can log into, right? This is the order of things that happen on your machine at boot. If you know this order, if something blows up, like right here, you see the kernel and RAM disk get mounted and run, but then the wheels fall off. You know it's going to have to do with accessing slash and invoking systemd. That's where you should focus your attention. Or it might be something wrong with the kernel and RAM disk that was loaded. But like you know on either side of that what's supposed to happen. And so that's where you're going to focus your troubleshooting. Right? If instead systemd is executing and you see all the services starting and then it falls off, but somewhere in here where the target was selected, and then we started to start all the services and do all the things to get the machine booted, and that's where we fell apart. So we don't then have to look at kernel and RAM disk because that's in the past. Instead, we need to look at things like what are the units being invoked by systemd, what are the error messages being left on the console to help direct our troubleshooting. All right, so that's the what good looks like. Any further commentary before we jump into a broken box?
I think this is a great diagram because you and I were talking before the show. A lot of times when you go into these whiteboard sessions, all my experience as a systems administrator, I get a feel for how these things work, but I don't necessarily have a list. Mine was pretty spot on, even just from experience. I feel good about that today. Sometimes I learn stuff from your whiteboarding sessions.
All right, so let's jump into my machine terminal. We have a problem already in existence. Everything looks fine. I can run a command. Everything's
Everything's
great until we reboot. And then the wheels are going to come off. There's my BIOS. I should see my grub screen next. Oh, it was too fast for us to catch. So
it
now
went
we're
too quick.
getting, yep, kernel and systemd messages. Now, because I chose graphical target, it's got this little thing where it's actually just like showing me that there's a progress screen. But if I hit escape, it'll turn off the graphical screen and it'll actually give me the console messages that are happening on the console. So cool. We loaded kernel stuff. We mounted /boot, and here it's going to kind of like have some problems. So
So if anyone's curious, that graphical boot that Scott had to turn off, if you run in a server environment where you'd rather the console not be hidden behind you, that you can turn that off via kernel command line arguments. So just FYI, I think it's the RHGB tag that ends up at the end of the kernel line. So you can remove that and then you'll get this text mode at boot. Just FYI.
yep. And it'll save you a little bit of extra memory. Not much, but a little bit because you're
Yeah,
not
I don't know
having
if that's why I was thinking. I'm thinking more like if I'm a systems administrator and I'm standing at the console, I don't want to have to hit an extra button just to see what's going on.
That's right. I like text to scroll.
Well, no, I mean I've run
Yeah.
into cases where like you plug in, like you switch to the console for via your KVM, and like maybe your keyboard and mouse isn't responding because they weren't noticed when the thing booted, and all you have is this graphical thing, and you can't hit escape because the keyboard isn't recognized. Anyway,
Yeah.
I'm a belt and
All right.
suspenders kind of guy.
Here we are. Machine has crashed. And what we get, look at that like red message that says time on it. It timed out. It says timed out waiting for device dev mapper rel-dat. And then it says, there are a couple dependencies that failed, and it was in the mounting local file systems task
Hmm.
that he was doing. All this diagnostic is like telling me, where do you need to focus? So we were mounting the local file systems, and then we broke. So I'm
Yeah,
going to
the one
focus
that
on,
yep, the one that it tells you right there, the one that failed slash data, right? So you have something to go on there, and it tells you
yep,
which device it had trouble getting to. Dev mapper
yep,
rel dash dat.
right. And because we had the machine booted and systemd was able to start, and systemd mounted the slash file system read write, we have like a half working machine. And so what we're getting here is a prompt to put in the root password on the console to get dropped into a recovery mode where I can try and fix this problem. So this is my machine, but it's not fully booted. It probably doesn't have networking yet. It may have some of the file systems, but not all the file systems, but at least it has slash accessible. Uh, and then notice it says, or press Control D to continue. Yeah, you don't want to do that because when I hit Control D, it's just going to reboot the machine. And then we're going to go through the same set of steps, and it's going to fail at the exact same place because I haven't actually fixed anything yet. So yeah, it's
You
tempting to
can't
hit
just turn it
Control
off
D.
and on again?
Right,
I thought
exactly.
that's how you fix these things.
It is misleading to think that you can just like, oh, Control D, I'm all good. No, you're not all good. All right,
I
so
should
let
have
me put
brought
in,
my I have a mug that says have you tried turning it off and on again? I should have brought that for today's episode.
I mean, it is the IT go-to. All right,
Yeah.
so I have my machine, and I could do something like df-hp. All right, and I can look to see what my file systems are. And so I have slash, I have boot. I don't have this thing that it was complaining about, which is slash data. And what I'm going to do is I'm going to cat etc epstab. And we can see down at the bottom, there's a listing for slash data.
Hmm.
And the complaint from earlier that's now scrolled up the screen was us having problems accessing dev mapper rel-dat. So it's
Yep.
a logical volume that is having problems. So if I do a LVS, there's my list of logical volumes that are recognized. And notice
Mm.
that one there is that, and yet when I look in the etcfs tab file, it's missing that last A. So the reason
Right.
it's not able to find this file system is because the device that I told it the file system lives on doesn't exist, so it can't find it to mount it at the mount point. But when I look at the actual list of logical volumes, I see there is a device called data. So let me go into etcfs tab, and we'll just fix the name to be correct, and then we'll exit the shell. So now that we exit the shell, it continues the boot process.
With your graphical login.
That's right, because server with GUI is the way. As I see producer Eric's eye twitching like crazy. Um,
This is into the terminal, Scott, not into the GDM.
all right. Yeah. All right. So notice that when I exited, it retried the thing that had failed, the local file system mount. And now it says it will successfully mount data. And we're able to continue on and boot all the way up, and everything's recovered. All right. So I said that this is a real life thing. And this happens all the time. You create a new file system, and
Yeah.
then you put the entry into etcfs tab, right? Because you like create the file system, you mount it, you make sure everything's good, and then you put the entry into file fs tab so that when you reboot, it gets automatically mounted again. Except, here's what you forgot to do. So you went to etcfs tab and you made a typo, but you didn't notice the typo because you just did it by hand. You were like, that looks right. Cool. And then you will get to experience the wrongness when you reboot that thing 2 months in the future when you're doing a
Yeah.
reboot for an update or something that you
Yep.
did.
Why did the
You have to
update break my system? No, it's the thing you typoed 2 months ago. Yeah.
exactly. So here's how you stop from having those problems. So you put the entry into etcfs tab, and now you want to verify it. So what we're going to do is we're going to umount data, right? So now
Mhm.
it's not mounted on the machine. And then we're going to do a mount-a so that it will, oh, and we have to fix systemd. Thank you, systemd, for telling me what to run. All right, let's try it again, mount-a. And now we get an error. So at boot time, we're trying to mount all the file systems, which is what mount A does. It experienced an error, right? Well, here's the same error, right? We can't mount slash data because the device dev mapper reldat doesn't exist. So you can go back in and fix your problem now while you're working on it already, so you don't have to remember what you're doing 2 months ago that caused this problem. So we can go into etcfs tab, fix our problem, reload systemd again. And now when I run the mount-a, it mounts
Ta-da.
cleanly. Yep. And I can verify that that device is mounted and everything is good. All right. So that's our first problem. Typo in etcfs tab happens all the time. Now we know how to troubleshoot and fix it. Nate, are you doing the next one?
Yes, I am doing the next one. All right. So I've got a system here that's already, like, I just turned this on in preparation for the demo, and it's already not booting. And Richard was in the chat talking about, we don't see any kernel panics yet. Well, here you go. Here's a kernel panic. I know it's cut off a little bit by our cameras, but you can see it right there. Kernel panic. So I'm just going to quick give this a reboot to show you guys what it's going to look like, because it does give us some information before it got to this point as to what the problem is. So we're going to click reboot here. Oh, that's not going to work. Hold on. I got to force reboot. There we go. And here, right, plain old grub. Just going to let it time out. And right there, it tells me it can't find the initram FS. Remember Scott's diagram from earlier? That's basically like the next step in the chain after it's loading the kernel, right? Here we are, kernel panic because of not being able to find the initram FS. Now, we talked about rescue mode before, right? Sometimes if you can't find the initram FS, it could be a really, really big problem, like there's data missing, or it could just be a simple typo, right? So in this case, we're going to do that force reboot again. And remember I said about this second option here in the Grub bootloader for rescue mode? We're going to try that first because it's so much easier than having to go, attach a RHEL DVD and connect that way. So let me just adjust this so you can see the console better. And here we go. Now, rescue mode, assuming it's not also impacted by whatever problem, and you can see already it's booting better, right? This will get us to a booted system, which, you know, maybe you'll just be like, cool, it's up and running, we're good to go. But no, we have to go find the actual problem. So we're going to log in as root here. And now if you were quick enough to catch it, right, it tells you the name of the file it's trying to find from the boot command or from the grub command line. So what you could have done is jotted that down, whatever, and then you can go look and see if that file exists. Those files exist in /boot, right? So in /boot, you can see there are definitely initram FSs in there. And if you had jotted down the version of the kernel that we were dealing with, it's 5.14.0, 427.13.1, you'll see, in fact, there's an initram FS right there for that kernel. So why won't it boot? Well, I don't know how well you can see it in the stream because of font sizes and whatnot. You can see there's a typo in the initram FS file name. There's 2 dots between the 13.1 and the EL9_4. So the grub bootloader told us it was looking for initram FS 5.14.0, 427.13.1.el9.4, but here the file name has 2 dots in it. So all we really have to do is rename that. Now, obviously, this is sort of a contrived example, but if for some reason you were doing something like building your own initram FS using Directories, it's possible that you could have built it and put it in place and then either not updated the grub configuration properly to point to the right file name, or you could have named it slightly differently than the system expected when it generated the grub config, right? So that's 2 ways that this could have occurred, right? So we're just going to go and fix that. initram FS 5 with 2 dots to initram FS 5 with a single dot. Gonna go back. Tab auto completion makes this so much easier to type. And now if I reboot, it should just come right up without me having to go into rescue mode. So this is a great example of how that second item for rescue mode is really handy. You could have also, if you're on a system that has had the kernel upgraded more than once, you'll have old boot entries in there for the old kernels. That's another great way to get into a system that won't boot. So if you're making changes to the most recent kernel and it won't boot now, you can boot the one from the last update, right? So, you know, whatever the most recent kernel is before the changes you just made. And there you go. My system's up and running again.
Awesome. So you ran Directories, you made the wrong file name and
Yeah,
blew it up.
right. You can imagine there's lots of use cases as to how that file might have gotten out of whack. Maybe you were changing the grub config manually. Maybe you were generating a new MFS and you just made a simple typo, like having 2 dots instead of 1, like I just had there.
Yeah. So if we switch back to mine, we'll have another machine that's busted.
More broken.
All right. We're going to boot this machine. And so we see the kernel load and it's starting to run. And actually, I'm going to escape here so we can watch the thing. System D has started. Everything's good. We're mounting local file systems and we get some failed stuff. And then another file system problem.
Emergency mode. Oh no.
Man, I terrible file systems today, Nate.
Yeah.
All right.
Yeah.
Put in the password to go into maintenance. So again, no networking. Some of my file systems are mounted, but not all because we were having problems mounting them. So why don't we cat etc fs tab and see what we should have, which is /data and mount. And then we'll do a df-hp. This is what we do have, slash and data. I don't see /mnt mounted. So let's just do that. Boom. Mount -a, it actually hits that line. It knows that that's the thing that's not mounted. And it says, nope, can't open dev sda2. All right.
That's
So
a
let's do
problem.
Yeah. All right. So let me take a look at dev SDA2. So etcfs tab says dev SDA2 should be mounted at /mnt. It's an ext4 file system. So that's weird. Unknown file system type.
Oh
Hmm.
no, you've totally hosed your file system.
So this is what things look like when you have file system corruption.
Yep.
And there's a bunch of different ways that can happen, but thankfully they're relatively few or they don't occur very often. But there is one tool that we kind of use to try and recover from file system corruption. So it is currently not mounted. So we're going to run fsck on devsda2. Oops, sorry, devsdb2. Man, if I use the right device. So it goes through and says, hey, we're going to do these checks. And so we check the inodes and the blocks and files. That's all cool. We look at the directory structure. That's fine. We kind of navigate around the directory structure. That's fine too. We're looking at references. So do the things in our directory structure actually point to files on disk, and can we find them? So if there's like half removed things, we can find that kind of stuff. And then here we go. Hey, there's some bitmap differences between what I think the size of the file system is and then what I actually see it on disk. So do you want me to
Hmm.
fix this? Yes. Oh, and by the way, the free block count is wrong. Group for inode group number 1. There's a missing block. Do you want me to fix that? Yes. The free blocks are wrong. Yes. The inodes are wrong. Yes. Keep saying yes. In fact, like when you're asked any of these questions, they all look like questions where the answer is always yes, right? If I wanted to, I could have just called fsck minus y to answer yes to all these
Yeah.
questions. I don't just have to keep typing yes.
I
All
always
right.
got iffy about that because what if it said, "Would you like to erase all the data?" Yes. No, no, I didn't want to do that.
Well, the fsck never asks you that because that's not what it
That's
does.
true. That's true. But at 2 in the morning, if it did,
So now that I have file system checked it and gone through and file system check has repaired all of these things that have found wrong on the file system, now let's do a mount dash a. Oh, and helps if I reference the right thing. It's not devsda2, it's devsdb2.
oh, see that? You had 2 failures going on here.
Yeah, this is what happens when when you put things in by hand and you just go, "Yep, that looks right."
Looks fine. Totally
That's
fine.
right. Systemctl. Man, I am
Very
having a rough day
loud.
today. That's right. All right, let's try this again. Mount dash A. Oh, it looks. No errors.
Hey,
F dash HP.
you fixed it.
Here it is, mounted at /mnt. And if we reboot the machine, let's make sure that it all comes up and everything's cool. All right, so there's my kernel initializing. Now systemd is starting. Systemd is starting to mount all the stuff. It started all the services. Yeah, we're looking pretty good. Like this is where I crashed out before. And bam, server with GUI. Mhm.
Just gotta rub that
So
in every time, don't you?
I do. I got to twist the knife. So in that situation, what happened was the super block on the file system had gotten corrupted. Now, I purposefully did that by using DD to overwrite it. But that's why things like the block count of the file system was weird because the first portion of the file system had been overwritten with garbage. The super block, which actually tells the mount command what the properties of the file system are and how to work with the file system, what file system format it is, that was corrupted and it couldn't be read. And so FSCK helped fix all of those things that had gotten corrupted on that file system by me wiping out the first bit of it and its super block. All right, Nate, what are you
Yeah,
working
I've got
on?
another horribly broken system. All right. So this one looks really bad, right? I mean, it can't find some data from grub core, fshelp.c file, yada, yada, and it's in grub rescue. Now, this, I could reboot this to show you what's going to happen, but it really doesn't do anything but get me to this error, right? So basically, grub can't find any of the stuff that it needs to find. So we don't have an option to go to rescue mode from grub because grub isn't even fully loaded at this point. Basically, grub's got no config to reference. It's got none of the files that it needs to talk to the hardware. It's just it's got it it's got the very basic grub bootloader that it got from the boot sector of the disk, and that's it, right? Now, in a situation like this, I mean, start to panic. Your server is down. Grub's giving you no options. There's probably some stuff we can do within the grub rescue environment to try to do some troubleshooting to try to identify what's going on. To cut time a little bit short, I already know what's going on. So what we're going to do is we're going to actually boot from the boot DVD, or actually the binary DVD for RHEL 9.4, which is exactly what I have running here, right? So first, we're going to force a shutdown because this thing is not working at the moment. And since this is a VM, I have to go back over here, click insert for a DVD. Libvirt, right? ISO's RHEL 9.4. Okay. We're going to click insert there. I've already got this set up so that it will try to boot from the DVD when I click run here. So I'm going to click run and get down to the console as quick as I can before it tries to do an installation. All right. So let me get the console a little better in view here. There we go. So this is what you'll get when you boot off of a RHEL 9 installation disk. Now, obviously, the default is going to be, I want to test the media and do an installation. Well, we're not there yet. We don't want to reinstall this system because we don't really know what's wrong with it yet. There could be data in there that we can resolve, that we can recover. There could be a way to fix the problem that we're seeing. Okay, so we're going to go down to troubleshooting. And in troubleshooting, there's a couple options here. We can install with text mode. That's basically if you have video issues in the graphical mode installer. We don't want that because we're not trying to reinstall. We're going to do rescue Red Hat Enterprise Linux system. Now, you can see there's also things like a memory tester here. You can tell it to boot from the local drive. Again, good tools to know that are here, but not useful for today's example. So we're going to go rescue a Red Hat Enterprise Linux system. And this is going to boot just basically a live environment from the DVD. And it's going to let us mount the disks that it sees on our system. Now, if it can't find your disk, you're in a worse boat than we are for this particular demo, but you still may be able to use some tools to see what's left on your disks, try to identify if there's any data you can recover, things like that. But first, we're going to try to recover this particular system. So you can do a read-only mount if you're worried about writing changes to the disks that might cause damage. We're not going to do read-only today. We're going to just hit number 1 to continue. What number 1 is going to do is it's going to look for partitions. It's going to look for logical volumes. It's going to look for an etcfs tab. And if it can find those things, it's going to mount them under mount sysroot, right? So we're going to do number 1, hit enter. Now it's going to start doing that scanning and stuff, try to figure out what's going on.
The mount sysroot thing is, I think, what causes people the most problems with rescue. So Nate put it really where he said it loads a live environment into memory. And so in that environment, there will be a file system, there will be tools, and then your box is going to be mounted at this other location inside of the live environment, which is mount sysimage. Right. So if we just, you did an LS at the top level, it looks kind of like a Linux box.
Yeah.
But that's not your Linux box.
Right. So this is the live environment. If I go into mount/sysimage, and do an LS, this is my actual environment, and the console is not cooperating with me. It's a little too tall for the live stream, but you can see here that we have what looks like our actual Linux file system here. Now, what it was complaining about was files that it couldn't find inside of boot. right? Or I should say inside of grub, but we know that the files for grub live inside of boot, right? So we're in mount sysimage now, right? If I do a pwd, you can see we're in mount sysimage. You can also use TraceRoute, which I'm going to do in a minute, to almost emulate your live system. So if you want to make changes to the system as though it is your system, you do a TraceRoute into mount sysimage. But we're not going to do that just yet, or mount sysroute, because we're still in like a diagnostic mode at the moment. So we're going to go to boot because, like I said, it found boot in my SEFS tab and it mounted it here. If we do a mount, you should see it. Well, here, let's do a df. We do df. You can see under mount sysroute, we've got mount sysroute boot, mount sysroute boot EFI, mount sysroute dev, mount sysroute home, temp, var. Those are all the partitions that I have in my actual environment. So, okay, so from here, we're in boot. Oh no. Boot is looking suspiciously empty. All it has is the EFI volume, which is where the EFI configuration exists, so that if you've got a UEFI BIOS, it can read that. But because boot is empty, now you might remember from my last demo when we were looking at that initRD, things live in here like the initRD, the kernel, a bunch of really important things to make your system boot, right? So boot is a pretty important partition.
Grub stage 2, the
Yeah.
configuration.
Yeah. So luckily, what boot does not have usually is variable data, data that you may have created that's hard to replace, right? It's got the kernel, which is something you can get from your installation media. It's got the grub binaries and whatnot to make grub work. It's got the config for grub. It's got the initRD. These are all things that you can either reinstall or regenerate, right? So we're going to go through and do that. And I'm going to show you basically how this works. So because now I'm going to caveat this. I have specifically crafted this environment so that this is easy for this demo. If you're on a system, this is a fresh 9.4 install. I've got the 9.4 DVD attached, okay? If you're on a system that is not completely fresh, which you probably won't be, the version of that kernel is going to be newer than what came from the DVD image. At that point, you've got choices. You can either revert to the one that came from the DVD image, or you'll have to go get the version that was running on your system, which maybe you know, maybe you don't. Your grub, well, no, your grub config is gone. I'm trying to think how you would know. The RPM database should be able to tell you what was installed, right? Which you can do by using TraceRoute. You can then use RPM to query the RPM database and say, what packages does my system know about? It'll still think the kernel's installed even though the files are missing. And then you can reinstall the RPM if you have it. In my case, I have it on the DVD. In your case, you may not. In which case, there's things you can do, like if you've got local repositories from satellite, you can get those mapped into the system. I did try to see if I could get my rescued machine to talk to the normal Red Hat CDN to get data, and I was having a hard time getting it to do that because subscription manager and DNF were not happy with the environment that I was in. Maybe with some more work, you can make that work, but just keep that all in mind as a caveat.
So, Nate,
All right, so we're gonna go. Sorry, go ahead.
one quick question. If I had a backup of my boot file system's contents, could I just restore that backup here?
Yeah, you could restore the backup. You'd probably, and at the end of this, we're going to do a grub2 install to get grub to refresh all of its files. You may or may not have to do that because the files that it replaces may be included in the backup, right? I haven't tried that, so I can't say for certain you can just restore and go. You may have to restore and then do a grub2 install. So, all right. So like I said, I've got the DVD image. It's already attached to the system. It puts it in /run. What was it? Repo? No. Install. No. Where is it? Yes, install. Repo. That's the contents of the DVD image. And I realize we're cut off by the cameras. I'm sorry. There's not, I guess I can do this and show you again. I'm having trouble with the console size here. There we go. So you can see there's the app stream RPMs and there's the base OS RPMs, good stuff. But how do I actually get my rescued system to use it? I could just go into those directories and do an RPM reinstall on the specific RPMs that I care about. The problem is dependencies are difficult to follow with the RPM tool directly, right? DNF makes that a whole lot easier. So it's a lot cleaner if I can use this DVD as a DNF repo, which, surprise, you can, right? That's exactly how the installation works. It sets up a DNF repo from the DVD media, and then it lets you install from that. So let me just get back to my notes here so that I don't mess up the scenario here and I don't waste everybody's time. All right. So the first thing we're going to want to do is we need to make sure that this installation media is available from within mount sysimage, right? Or mount sysroot, sorry. No, it is sysimage. So we're going to use mount. We're going to use a bind. Now, there's other ways to do this. You could probably symlink it, I think. No, that wouldn't work inside of TraceRoute. The mount bind is probably the cleanest way to get this to work. We're going to bind /run/install/media. No, not media, repo to /mount sysimage. I guess we'll put it under mount. Okay. And what this is going to do is it's going to make a link between those two, right? I don't know if hard link is the right word here, but what it's going to do is inside of my file system, all the calls that go to mount sysimage mount are effectively the same as run install repo, right? Now we're going to use that chroot command, which we can argue about how to pronounce chroot. I know there's a lot of different ways. Chroot, whatever. Change root. We're going to chroot into mount sysimage. And now, if I do a pwd, it looks like I'm in slash. ls-l shows me the data from within my system that was mounted, right? And if I look inside of mount, there's the contents of the DVD. But it's not a repository yet, right? Now, what you can do is you can manually create a repo file, but there's this media.repo right here inside of the root of the disk here. If we do copy mount media.repo into etc yum.repos.d, and then we're going to have to edit it.
And while you're doing that, Nate, I just wanted to, we said root into mount sysimage and then kind of glossed over it. But what we're doing is you're creating a subshell where it is,
Right.
its environment inside your subshell is constructed such that it can only access what's in mount sysroot. It can't go outside of that directory structure. And so you've changed the root of the file system for that shell, hence the chroot, to mount sysimage, and that's, you're like locking it down in that sub environment for your subshell.
So what I've done is I've added a line at the end, and again, my console is a little bit bigger than the screen here. Let me scroll up. I've added a line to the end, base URL equals /mount/baseOS. BaseOS is the repository for baseOS. I don't need the AppStream repo, but if you needed one, you could make another copy of this, give it a new name, and also do AppStream. But for this particular repair, we only need baseOS. So we're going to save that. It's read only because I copied it from a DVD and it didn't copy the read write flag. But since I'm root, I can say write it anyway, dang it. So I did. All right, so now if I do a DNF repo list, we should have a repository called install media, because that's what it was called inside of that repository file. So there we are. Now we have the ability to do installations and whatnot. So what we're going to do is do a DNF reinstall. So reinstall basically says, hey, there's a package already installed. I'd like to reinstall it from my repository. What that's going to do is it's going to find the version that is installed, find the version in the repository, and reinstall that specific RPM, right? We're going to do a DNF reinstall on kernel star, which says any package. I think it's any installed package with the name kernel. It should be any installed package with the name kernel. And then we're going to do grub to -star. And what that'll do is any grub2 package. Now, you probably don't have to do all of them, but I didn't go through and find exactly which ones I need to reinstall. And this isn't going to hurt anything, right? So what we're going to do is let's make sure I didn't miss any here. I think that's it. It's going to do a reinstallation on all those packages. And you can see there's grub2 common, grub2 PC, yada, yada, yada. Then there's a bunch of kernel core, kernel modules, kernel tools. We're just going to say, yes, go ahead and do that. And the cool thing is when you install a kernel package, it also does things like regenerates the initRD. And when you reinstall grub, it's doing things like reconfiguring that grub config file, which is also something that's missing that's inside of boot. This is all running within those scriptlets that run after the package installations.
And
I
actually,
promise
Nate, that's
we're almost done. Go
a
ahead.
great segue. Our next episode, we're going to be talking about package installations. So scriptlets, man, there's something not many people know about.
Good old scriptlets. So yeah, it's probably building the initRD right now. So let's give it a minute. But once this is done, you might think, hey, we might be ready to reboot. I've installed the files, right? Well, there's one more step afterward, which we did talk about earlier, if you're remembering. I tell you what, before this episode, where we tossed around the idea, what if I just delete boot? You think we can recover from that? Scott didn't have any faith in me.
That's not true. Always have faith in Nate. I just think it's arduous, and man,
Just
it would be
kind
nice
of.
backup to restore from.
Oh yeah, a backup would be a much better way to recover this particular scenario. But if you don't have a backup, because who backs up boot? Who would back
Yeah,
up?
well,
There's no data in there I care about.
yeah, and so like the places where this actually happens, like everybody's like, why would you remove boot? You don't do it on purpose.
Exactly.
You were DDing and you accidentally DD'd over dev SDA and figure that out and were able to control C it, but you've corrupted boot, right? So you have to
Yeah.
like load your file system on it, and then you got to recover all the stuff that's in it.
All right. So let's see what now. We do an ls-l on /boot. And look, it's looking really handy now, right? This looks like we're done, right? We've got the grub2 direct subdirectory back. That's where it said those files were that it was looking for. It's got a config and initram FSs. It even restored the rescue environment that we were talking about earlier, right? You can see all the stuff is there. System map. If I were to reboot now, though, it's going to give us the exact same error. And the reason for that is I didn't do a grub2 install. Now, this may not be required for every particular scenario, but in this case it is, because I've basically wiped out a bunch of stuff under boot, which is generated by the grub2 install. That boot sector is probably still there. In fact, we know it's still there because grub tried to load before, but the supporting files are not, and that's what grub2 install is going to fix for us. So in my case, this is dev VDA, and it's going to basically figure out where the files need to exist, which is, I guess, included in that boot sector. I'm not really certain how it knows where boot is, but it does figure it out. And then if we do an ls now in boot, I think it's underneath, was it under loader? I forget which files it couldn't find. No, it's not under loader. It's under grub2. Yes. See this i386-PC? That's the files it couldn't find before. And I should have showed you earlier. They were not there, and now they are. All these files get written by the grub2 install. And at this point, we can reboot the system. So we're going to exit the chroot environment. We're going to shut it down. And yes, I just typed init 0, even though that's kind of old school and not required. We're going to disconnect that. Sorry, go ahead.
If you exited the shell, it would kick off a reboot, but I know that you don't want to reboot it because you actually want to disconnect the DVD.
Yeah, right.
Yeah.
So I've ejected the DVD image. Now we're going to run it again. See if I can get this up before it tries to boot. Look, grub already looks better. And here we go. As long as we got all of our T's crossed and I's dotted. Oh, it's going to do an SELinux relabel because we booted into rescue mode. The system is smart enough to realize that. It probably wrote that auto relabel file, which a lot of maintenance processes will do. So it just did an auto relabel to make sure that all of our SELinux contexts are good. And now it's rebooting. And it should boot right up.
The reason that's important is that while you're in rescue mode, the rescue kernel isn't running SELinux.
Right.
So as you're like messing around with files and file systems, like adding those replaced packages, the SELinux context for those files was not being written.
Right.
So when you reboot the machine into an SELinux kernel or SELinux enforcing kernel, it wouldn't know what to do with those files because it doesn't have any contexts. So the relabeling is really important to like make sure that everything gets trued up after running in that non-SELinux enforcing mode.
Right. And there we are. System is booted again. We can go back to bed and silence the pager.
All right. We're going to be talking about troubleshooting package transaction problems. Nate, do you want to jump us into a terminal and we can take a look at some of the tools we can use for troubleshooting
Sure.
packages?
You may be familiar with a bunch of them already, but the first one we're going to talk about is DNF, which if you're on an older RHEL system or if you're used to older RHEL terminology, it's almost interchangeable with YUM. So DNF is the package manager that comes with RHEL. What DNF does is it reads package repositories, which are, in the case of RHEL, provided through your subscription. We'll talk about how subscriptions are attached in another tool. This is basically how you interact with your repositories. So I don't know, if we just wanted to do a couple of example commands, maybe we want to search for, I don't know, give me something to find, Scott. What's your favorite package?
We always do HTTP, although that may be installed on this box already.
If we do a search for HTTPD, it's going to come back with all the package descriptions that include the term HTTPD and the package names that include the term HTTPD. You can see they're sorted. Name exactly matched versus name and summary matched versus just the summary matched. It's really handy that it does it that way. You can also do a DNF info on a package, and it'll tell you if it's installed or not, what version's installed, where it came from. You see this one came from the AppStream RPMs repo. Right. So there's some basic installs and removes, I should say, with DNF. We're going to cover a bunch of that stuff as we're going, but just a quick installation example. Here, let me reset the screen here. And the nice thing about DNF, which anybody who remembers the days when we were dealing with just RPM, is that it does dependency resolution for you. So if I did a DNF install on, I don't know, we'll just use the good old HTTPD, which I forget if I saw if it was actually installed or not. It's not. So you can see it's not just installing HTTPD. It's not just installing packages that include the word HTTPD. It said, okay, HTTPD needs these other things. And it did that dependency resolution. You can see right here, it says dependencies resolved. And these are the things that you must have installed in order for HTTPD to function. Bare bone, bare minimum, right? Will HTTPD run? You need these things. Now, obviously, you can install other add-ons for HTTPD, and they'll do the same thing. For example, if I tried to install, I don't know, HTTPD core, it would have also said, well, you need HTTPD as well, and it would go and get that. Another cool thing it'll do is, sorry, go ahead.
That was the other thing that RPM natively was not great at, was when two packages depended on one another, but DNF and YUM, its predecessor, both do really great with that.
And one last cool thing I want to show you is you can manage groups of packages with DNF. Now, these are, I forget exactly how they're defined in the repository metadata, but you can define groups within your repo. And those groups can then be installed with a single command, right? So if I wanted to add server with GUI, if I wanted to add virtualization host, which is one that I commonly do whenever I'm setting up my home lab, it's like a meta group of all of the things that would be included. If you're familiar with the Anaconda installation wizard when you're installing RHEL, if you check the box that says this is a virtualization host, that's the set of packages it's going to install. If you install the minimal install and you're like, you know, this machine really needs a GUI, you can do a group install on server with GUI, right? And then you'll get the server with GUI.
That's all stored in an XML file in the repository. It used to be called comps XML. It may have had a slight name change over the years, but that's where it not only defines the name of the group that's displayed and things like the output that Nate just showed, but also what RPMs are required as part of the group and which ones are optionally part of the group.
Right. Okay, then the other tool is RPM, which is the tool that actually interacts with packages. And I don't really have a lot of actions I planned to do with this one. But if we do a --help, you'll see that there's a bunch of actions you can perform. And this is if you have an RPM file you want to install. Now, it's generally better practice to use DNF to install, even if you have a direct package you want to install. There's an RPM database that exists on the system, which tells RPM what's installed and what's not. Never lose that file. If that file gets lost, your package manager is hosed and it's very difficult to recover from. I had it happen once so bad that I had to reinstall my server. It was not great. So don't lose that file. Anyway, it will interact with that database, and that database, I think, gets refreshed by DNF next time you run it. But you can also do a DNF local install, or maybe it's even just DNF install now, and point it directly to an RPM, and it'll do the same thing RPM was going to do, except it'll also do the dependency resolution. Why not use DNF instead of RPM? But
Yeah,
just know
well,
that there.
the
Sorry, go
reason we're
ahead.
covering PM is because for some of the more advanced things that
Yes.
you mess up, you may not be able to do the diagnostics that you need to do with DNF. DNF is about dependency resolution and transaction tracking, but RPM is what's actually putting the files around your directory tree and storing a lot of other data in its database. So
Right.
the reason we're covering RPM and the reason that we'll see it later on the show is because we're going to be using it to get at that next level of diagnostic information for our
Right.
host packages.
So I just did two things while you were talking. One is I did a -QA on RPM. That shows me all the packages that are installed on this system. Now you can get a similar list out of DNF, but RPM, sometimes it's just a little more of a fluid tool to get this done with. But the other thing I got was a package description out of the package that was already installed with -QI. And there's a whole bunch of other commands, which we'll touch on as we go throughout the episode, that you can do some more debugging and whatnot about the state of a package. All right. And the last one is Subscription Manager. We have the Remote Host Configuration Tool, RHC, now, which can also be used for registering your system and connecting it to Red Hat. But Subscription Manager is the tool that's kind of still in most people's minds, the de facto standard for getting this done. If you do Subscription Manager register, it'll take you through an interactive prompt. It'll ask you for login information to the Red Hat customer portal, and it'll register your system with Red Hat. And then you can attach subscriptions to it through Subscription Manager. If Rich Dorito was watching me, he'd probably slap me for using the word subscription, because there's a whole lot of work being done to improve that experience. This is kind of the old way, but it's the
Well,
one that most people are familiar with right now.
yeah, and this is the one command you use to register with Red Hat. There is also an activation key option that you can pass, which is a token that will
Yes.
prove your authenticity and register you with your account. But the reason that I want to cover here is really not the registration, but subscription manager status.
There's
Yeah,
also listing repositories that you can attach, which is what I just did. But Subscription Manager status will let you find out, like, am I registered? Do I have packages from Red Hat? That kind of thing.
right. And for example, I know in the past we've covered things like the EUS repositories, so you can stay on a minor release for a longer period of time and still get
Hmm.
important security errata. The EUS repositories show up in that repo list if you have it attached to your account and this machine is eligible for it.
Yeah,
That
Subscription Manager repos dash list will show you all of the repositories that are available to you, and then you can attach or detach repositories as you'd like. Subscription Manager status gives you the output that you've got right here. This tells me that I'm using simple content access mode, so there isn't a whole lot for the status to tell me. But if you weren't using SCA, it would give you a slightly different output. I think it tells you what pool you're attached to and things like that, which is, again, kind of the old way.
but the big thing is it didn't give you an error about not having a subscription.
That's the other
So
thing.
this is basically because it's not erroring out telling you that you have a valid subscription. And when you do things like repo list, you can see the repositories that are coming from Red Hat so that you know that you're getting software.
Right. And another good thing, which I didn't cover when we talked about DNF, is repo list inside of DNF, which tells you what repositories are currently active on your system. I think there's a way to get that from Subscription Manager as well. But this is a nice, convenient way to get it when you're working with DNF. So, and I think that's our tool set. Is there anything else we wanted to cover? I think that's all we have in the notes.
Yeah, I think that's it. So DNF or Yum, depending on how old your release is. Subscription manager, just to make sure that you're registered and you're active so that you get the Red Hat stuffs. And then RPM is what we're going to use for all those much deeper queries and much deeper information about what the packages are actually doing and interacting with the packages on our machine. So
Hmm.
let's talk like what happens during a normal package transaction. And it's going to be kind of a flow chart. And then we're going to jump into a bunch of problems that we've seen in our lives and how you would go about approaching and fixing them. Nate has like 11,000 problems. Of course, I only have one. So there you go.
It's payback for all those weeks that I missed.
All right. So now is the part of Into the Terminal where we interact with the audience. If you have questions, please post them in the chat. Eric, myself, Nate are all in there looking at it as well. Why don't we go ahead and jump into our whiteboard and see what a package transaction should look like. Nate actually went through one of these with DNF in the critical path. Essentially, we ran DNF install HTTPD a few minutes ago. And when DNF started that transaction, the first thing it did access your repo metadata. So you said HTTPD, and he needs to figure out what you meant by that. What package, what version is available, what repository does it come from, what dependencies are required, accesses the repo metadata, and then does things like dependency checking. And once it figures out what dependencies are, then it needs to make sure those dependencies have been satisfied. We're going to do a couple of these. Until we're sure we have not just the dependencies for the package we named, but any dependencies of its dependencies, so that we have everything in a good shape and all the software we're trying to install has the stuff it needs to operate correctly.
Which,
All
by
right.
the way, used to be a manual process. RPM
Yeah.
install foo. Oh, I need this, this, and that. Okay, go get those. RPM install those. Oh, those need this, this, and that, and so on and so on. DNF. I mean, uh, when Yum came along, it's just a complete sigh of relief the first time I installed the package, and it just resolved everything and installed them. Every package manager today does that for you, but RPM in the old days was some dependency hell, we called it.
Thank goodness we don't live in 2001 anymore and have advanced ourselves. All right. So at this point, we know what our package transaction should look like. Transaction summary. It says, here's what I'm going to install, right? And that's where we saw like HTTPD, HTTPD core, HTTPD file system, mod SSL, and like all the other things that were on that list. And then ask you a question. Do you want to proceed? Yes or no? So at that point, you can say, I'm not happy with this. Let me go back and adjust my transaction. Or yes, this looks right. Go ahead and do it. Once you say yes, it downloads everything. So it's going to collect those things from the different repositories that it needs to get the stuff from, and it's going to put them in the var cache DNF directory for those repos.
There's commands for DNF that will let you flush that cache if for some reason you need to. If you're having weird package dependency problems, sometimes it's because the cache is messed up. You can just wipe
Yeah.
out the cache and it'll re-download.
Well, and also I said it accessed the repo metadata. Turns out that's also stored in var cache DNF. So
DNF
sometimes,
clean, I think, is the command.
right, and clean all will remove all the metadata from var cache shown. But so that is something that also will occasionally happen where it doesn't look at the configured repositories every time, or maybe something's gotten munged in transit. But you can get yourself a fresh copy of repository data by doing a DNF clean all and then do your DNF install or upgrade. Again, and it'll freshly download all that metadata. But we try to keep our package transactions fast. All right, so we download everything. And now we have all the RPMs that we need to install. So then it's going to move to installing them. Download them all, and now it's going to install them all. It's actually doing RPM transactions in the backend. When you're watching the DNF output, it'll say installing or it'll say upgrading, and there will be a status bar. During this stage, what it's doing is taking the files out of the actual archive of RPM format and starting to sprinkle those files and directories out into your machine's file system. It's going to pull the executable binary for the Apache web server and throw it in user sbin. Take the configuration files and put them in etch-ttpd, and it's going to take the document root and stuff and put it in var www, because that's what the file manifest that's included in the RPM package says to place all these files. And we did an episode a while back on creating RPM packages. So if you're interested in that, there's already an episode in our library that will actually walk you through how does one create an RPM. All right, it'll also take care of doing things like registering all the content that it just put on your machine with the RPM database and with the DNF transaction database. So it takes care of that as well. And we'll go into a little bit more depth on installing RPMs in a bit, but not only does it actually sprinkle the files around, but there's also some scripting that can be executed. So if you have to make sure the machine is in a certain state before you start installing the packages, you can do that as a administrative task automatically as part of the RPM install. If you're erasing something and you need to make sure that something gets erased because it was a runtime created file or something like that, you can account for that in a post uninstall or pre-uninstall script that's included in the RPM package data. So there is some scripting that could happen and generally does happen during this installation stage. All right, during the verification stage, that's where it's like making sure that everything installed correctly and didn't produce erroneous output. And that's going to set things like the status of the package transaction in the DNF database. We'll do any cleanup that is needed as the very last step. Some other things that might need to happen, things like you install kernel and we have to do a grubby install to make sure the kernel is put in there. That's probably part of the RPM transaction scripting in the install RPM step. But there's a whole bunch of stuff happening behind the scenes. What you get to see is this transaction summary. I'm going to provide the transaction, and then it'll give you a success or failure message at the end, depending on what happened during the package transaction. So at any one of these spots, knowing how far you're getting in this transaction and looking at the error message will help you figure out what you need to do next to troubleshoot the problem.
Is DNF is really good at telling you what stage it's in. If you watch a transaction as it's playing through, you can tell where it is. It'll say, okay, I'm doing package cleanup now, or it'll say, I'm downloading packages now. So it's usually pretty easy to identify if you're watching the screen where it died.
People always ask about automatic updates.
Hmm.
And I have historically always said I do not care for automatic updates because we schedule them to be there when we're not there, right? Because like that's the whole point of automatic updates. They just happen to be
Why are they automatic?
right. The problem with automatic updates and why I don't do it is because I lose the ability to observe this. And I may even lose the diagnostic output that I would see if there were failures in this chain. When I do a DNF installer update, we're going to access the metadata for the repositories that I have configured on the machine. That's going to let me figure out what packages I need in my transaction. The next step is going to resolve the dependencies. So it's going to go back out to those repositories and make sure that I have all the packages that those packages rely on and that those packages rely on. Then it's going to present to us a transaction summary. It's going to say, here are the packages I plan to do during this transaction, and it will have an approval, yes or no. The default is no. So if you just hit enter, it'll bail out of doing anything. If you hit yes, it'll start processing the transaction. When it starts processing, it will download the RPMs it needs from the repositories, and it's going to store those in var cache DNF in some subdirectory structure down in there. Then it'll do the installation of the RPMs that were downloaded. So it's going to put the file package content into our directory structure. It's going to run scripts. It's going to register with the RPM database. It's going to register with the DNF database as well. That goes through the verification checks, making sure that the package transaction history is correct, that there are no errors. And the last thing it does is it cleans up. So if there are any things that need to be removed, it'll execute that during the cleanup stage. So that's our flow.
All right.
So, Nate, we're going to have some problems now, right?
Yeah, because that's what we're all about. Problems and solutions to those problems. All right. Set up a scenario here. I'm a system administrator. I have been asked to make a very minor change to the Apache configuration file. So I use everybody's favorite editor, Vim, and I put in etc httpd conf httpd.conf. Except instead of getting my handy dandy Vim editor, I got an error that says Vim command not found. This seems pretty simple, right? Vim maybe isn't installed, or maybe there's something wrong with Vim. First thing we might want to do is figure out what provides Vim. There is a DNF command that you can tell it there's a file I really need, but I don't know what package it comes from. And that's called DNF provides. Now it's just provides. I don't know what provides was too hard to type, but anyway. Provides, and then you give it an absolute path. User bin Vim. You can also use wildcards in this. So if you did like /vim or /bin/vim because you're not sure, hit enter, and it's going to say, oh, that's provided by these packages. It's provided by Vim Enhanced. Okay, I thought there were other packages that might include Vim, like Vim Minimal. I guess not. All right, so now we know what package we care about. Let's see, maybe I need to install it. So if I do a DNF install on Vim-enhanced is a hard word to type. And now it's going to check the RPM database, and it says Vim's already installed. So now here's our actual problem. The package is installed, but we still can't get to the binary. Binary is not where we think it is. What do we do next? This is where some of those diagnostic tools that we talked about earlier can come in handy. If we do an RPM, here, let me get it to the top of the screen again, RPM-V, this will verify an installed package. Then we give it the name of the package, Vim-enhanced. What it's going to do is it's going to take the metadata it knows about Vim Enhanced, and it's going to say, what are all the files that should be here? And it's going to see if they're here. And sure enough, it says missing user bin Vim. All right, so the package is installed, but user bin Vim is missing. In this case, it's because I deleted it, but it could be because someone moved it. It could be because it got corrupted. Maybe somebody's deleted it on accident or renamed it. So the thing that makes sense at this point is if we really want Vim back, we just reinstall it. So DNF reinstall Vim-enhanced. And what it'll do is it'll say, oh, I've already got Vim, but obviously there's something wrong with it. You've asked me to reinstall it. It'll actually go through the procedure of removing and putting back the package that is installed. I don't think it'll go to the latest version. It'll do the one that's existing on the system. So if you're working on a system that you don't really want a newer package, it'll reinstall exactly the one that's already there. And if we hit yes, there we go. Now if we go back through our history and open up the Apache config, there we go. Vim works again. So now you know how to fix or reinstall a broken package.
And what happens if you RPM-V on that?
RPM-V, now it should come back with nothing because no more missing files.
Yeah, and so that verification actually checks a variety of metadata properties about those files. It checks to see if they exist. It'll also check a MD5 checksum that was made when the package was installed, so you can see if the file's been modified. It'll check the size of the file, or check the ownerships of the file, and it'll check the permissions or mode that's on the file. If you take a look at the man page for RPM and look in the verify section, it'll actually have a key of different properties that you can see in the verify.
So I just went and took a binary that was not Vim and replaced Vim with it and did a -V. And sure enough, here it is. Like, this doesn't look right. I don't know what these flags mean. That's probably in that man page we're talking about. You said look at the man page for RPM?
I can just tell you.
Okay.
So S means the size has changed. We knew how big the Vim binary was, and now this binary is not the same size.
Right.
5 is the MD5 checksum has changed, so the content of this binary that's called user bin vim is not the same. T last modified timestamp of this file has changed. The other properties that we track have not changed, and that's why they're represented with dots. If you want to see the full list, that's where you go to the man page and look.
There is a security feature of RHEL called File Access Policy Daemon, which will actually monitor and enforce these things, right? So FA Policy D you can tell it to enforce MD5 checksums, for example, and it'll use the RPM database as its input. And if Vim changed, then when someone tries to run it next time, just assume that it wasn't just replaced with man, which is what I just did, but someone put malicious code that maybe still runs Vim, but has some sort of a side-loaded thing in Vim that runs something malicious. It'll know, and it'll prevent you from running it. So just a nice, helpful thing to know about. All right. Any questions that came up in chat?
I think we're ready to move on to rolling back a transaction.
So this one's actually relatively easy. I just happen to have it queued up in a separate tab already. All right. We talked about transaction and the history log that DNF keeps, but I wanted to highlight what it looks like. If we do a DNF history, we can see actually the transaction history. And there's a couple examples that we're going to have today that could touch on DNF history. This is literally all the things that have happened. Now, most of these things are things that happened during the instantiation of our lab environment, right? These upgrades and updates and history that already comes with our lab environment. But some administrator has installed the server with GUI on my machine, and I have noticed it, and I'm not happy about it. So I want to take that back out. Right now, obviously, this is a contrived example. This could be something simple like I installed something and now my system is not acting the way I want it to. In this case, the way it's acting that I don't want it to is that it has a GUI installed. But imagine I upgraded my database engine and now my database doesn't start, or it's acting differently or something, right? Now, those are few and far between, but they can happen, especially if you're updating packages and you're like, I just need production back. You can roll it back with a command called DNF history rollback. The way rollback works is you tell it which number in that list to roll back to. So it should take me back to the state that I was in at 13. Now, there's also DNF history undo, which you can cherry pick one out. So if I installed 3 packages in separate transactions, and the middle one, number 2, is the one I really want to remove, but number 3 and number 1 I want to keep, you can say DNF undo and then give the ID of just the one you want to get rid of. So those are 2 different things that you can do. But we're going to use rollback here. We're going to roll back to number 13 in the list, and it's going to figure out what number 13 was, and it's going to go through all of the steps that Scott just described in his whiteboard session, do all the dependency resolution and whatnot, and decide what packages have to be ripped out. And as you can see, Scott, this is why I don't run GUIs on a server. Look at all the packages it's about to remove. The summary said something like 623 packages and downgrading on 40 of them.
I mean, maybe he's just misunderstood.
And this is going to take forever, but the whole point was I wanted to show you that I just tell it yes, and it starts doing the transaction. This does take, I don't know, 10 minutes to do the actual work. So we're not going to sit and watch it complete, but you get the idea.
And I like rollback because if you picked transaction 7, it would go back 14, 13, 12, 11, 10, all the way down to 7 in the correct order. Whereas the other one we're going to show in a bit is undo, which is like grabbing one, undoing it, and then.
Yeah, if you had done 2 things in succession, both of which had to be undone, then rollback is probably the way to do it. But if you want to cherry pick one specific thing out, then undo is the one you want to think about.
Yeah, in the chat, Granite Penguin asks about the workflow for rolling back a transaction when it was a kernel update. Kernels are not upgrades. Typically, when we're doing an upgrade of a package, we're deleting the old version and putting in the new version. But kernels are installs. We install the kernel to keep all the other kernels there with it. There are a couple of configuration things like how many you should keep. So if you get
Mhm.
over a certain number, then DNF will go ahead and take care of removing some of the older ones. The kernel is not just one RPM, it's a set of RPMs. If you try to erase a single thing, that doesn't work great. Also, the actual RPM called kernel and a version number is a meta RPM, where its dependencies are kernel core, kernel modules, and something else.
Kernel
Um,
headers.
uh, we're not going to go into a more depth because we have a couple other examples of transactional things that could be broken. But I would like to point out that this was recently asked on the Red Hat subreddit, and there was a bunch of traffic there on what one should do. Somebody posted basically, I think what you're getting at, which is I tried to erase this thing, but when I look in boot, it's still there. Like, what's going on? They talked about the process, and there's a K-base article for it as well. All right. Next problem. And this one's going to be one that I've set up. One of the things that I've seen happen is we're installing a package, and we can go ahead and jump into the terminal. We're installing a package, and the package transaction gets interrupted. So I've set up this transaction. It's a HTTPD update, and we'll just go ahead and say yes. To update it, I'm going to hit Control C a bunch. You can see that there were some error messages that resulted from me hitting Control C. So try to go through the thing, but when I was hitting Control C, we got a couple of errors. And these errors are talking about scriptlets. And this is one of the things I talked about early in the package flow or troubleshooting toolbox with RPM. You need to use RPM to get at this next level of information. We're having these scripts fail, and I'm just going to do a RPM q dash scripts on the web server. All right, and there are several different types of scripts. Some of them you see here. These are defined when you compile a package. It's one of the optional things, is a packager that you can put in. Post install scriptlet. So after we install the RPM and we've put its content around in the directory tree, we're going to execute these commands. A pre-install scriptlet. So a pre-uninstall scriptlet, before we remove this package, we're going to run these commands. A post-uninstall scriptlet. So after we remove the program, we're going to do these things. And a post-trans scriptlet, when we do a package transaction with this RPM, and after the transaction is finished, like an upgrade, we're going to do these commands. And there's a couple that are missing out of this list as an example. So there's also pre-install scriptlet, and there's pre-trans scriptlets, and there's a few more in there too. But what I wanted to do is highlight one, that we got errors when we were doing our package transaction, right? So let me show those again. Right, our scriptlet failed. Well, the scriptlets are things that will make that software work on this machine. In addition to putting the binary files or configuration files around, there may be other things we have to do, commands we need to run to make sure that man pages are cached, or that a new library we've dropped into place is reflected in the system configurations. When we run that binary, it knows where to find the shared object library it needs to load. And because of this error of the scriptlet not executing correctly, those things may not have gotten done. So we have a couple of options. One is we can go into the scripts like I just showed you using RPM and take a look at what was executed, and then we could manually like copy and paste it as root to try and redo things. But what was done, what wasn't done, it gets really sloppy really quick. So I think instead what we want to do is undo this transaction and then do it again. So I'm going to do a DNF history, and we're going to do a DNF undo 15. Sorry. DNF history undo. Yes, I want to undo that transaction. And then I'm going to put it back into place with a fresh DNF update. And this time I won't mess with the shell while it's updating, and it'll successfully complete. But you can see that no error messages were produced. So
Now, if you
what,
did DNF history again, just to show, you'll still see the one that he undid is still in the history. And also, I think the undo command also shows up in the history. Yeah, so history undo is there as well. So if you wanted to undo the undo or roll back the undo, you could. But the point that I was going to try to make was the number 15 that he undid, still there. You could also do a redo on 15 at that point, which would effectively do the same thing you just did by running the update again. So
well, but
just
we're pre-show, and because the redo is going to do
well,
things
hold on.
actually.
Pre-show, we're like, okay, redo will maybe redo some of what you broke. Maybe it won't, because the scriptlets may not refire if the package didn't get reinstalled. But if you undo number 15 and then redo number 15,
Got
that'll
it.
rip out what didn't work and it'll put it back in the same command that was executed when you did the update HTTPD, which is effectively the same thing you did. But my point is that you can do it either way.
Yeah. And I like doing an undo and then re-attempting my transaction because I know what that should look like. If you're a transaction, there's always a question of were there pieces that got missed because the package was unpackaged on the machine, but maybe something in the metadata or whatever didn't get executed right. So I like to just know the state of my machine by completely wiping it out and then putting it back into place. But some other examples of how this could happen, there's a power failure.
Right.
Right? So you're in the installation, and then for whatever reason, there's a power failure. Somebody rebooted your machine unbeknownst to you. So you have this like half finished transaction that you need to get rid of and then attempt again.
Right. Right. Or
Um,
some other process, you're in a maintenance window, some other process rebooted the machine, but you were in the middle of updates, which you could argue was poor planning, but it could happen, right? Things happen at 2 a.m. that maybe you're not proud of.
right. All right. So Nate, you're going to take us through what happens if I installed sketchy things and how do I know?
Right. So obviously, there's lots of ways to add third-party repositories to a RHEL system or any other system that's backed by DNF. And in some cases, that's not necessarily the way you want to operate. If you're in an environment where you have to know where your software came from, you have to have that secure supply chain, but somebody maybe installed a third-party RPM and that's not okay for your particular standards, right? I'm not saying that third party RPMs are necessarily malicious or necessarily bad. In some cases, you have a certain compliance level you have to meet. And having a third party RPM in there could take you out of compliance. All depends how strict you are. I actually did some looking. I was hoping there was a DNF command that would just tell me, like, hey, anything that's not signed by this key, can you tell me what it is? I couldn't find one, but there is a nice RPM query command that if you do QA, which tells it to query all packages, and then there's a query filter that you can apply, or a query format, I think is QF. And it's ugly, but I'm going to paste it in here. Just a sec.
I was going to say, you said it was a nice command for varying descriptions of what nice means.
It's what it does is nice. How it looks is terrible. So I'm going to make sure that this gets included in the description of the show so people can copy and paste it. But basically, what this is telling RPM to do is this -qf, right? Is this query format. And it's basically pulling out it's pulling out the PGP signature and giving you certain data out of the PGP signature, right? And this is going to do it for all installed packages, right? So you can see that there's the vast majority of our, let me pick one that doesn't get blocked by the little popover. The vast majority of our packages that are installed are signed by this particular key ID. Now, if I were to just copy one of these commands here, one of these package names, if I do a RPM dash, what was it, QI, I think, and then the name of the package, it'll tell me that is packaged by Red Hat. And of course, it still gives me the key that it was signed with right here. There's the signature, right? So you might say, all right, I don't care about packages that are signed by this key ID because that's not what I care to filter out at this moment. So I might do a grep-v for that key. And if you're not familiar with grep-v, this says grep for things that are not this. Find anything that doesn't match this pattern. And now I'm down to just, what is this, 7 or 8 packages, right? These all have Google in their name. And since I know this is a Google Cloud Platform system, right, because of the lab environment that we use, it's pretty easy to say that's probably Google's signing key. I could go look up one of those packages, or I could go look at the keys that are stored in RPM and tell, yeah, that's Google. But then there's this one here. Network Manager Open VPN. Let me just grab that one, and we're going to do that same RPM-QI on that package. And there we go. We can see that this came from the Fedora project, which actually I grabbed this from EPEL, right? That's who signs things that are in EPEL, is that it's signed by a Fedora project key. So now if I've decided I really don't want packages from EPEL, I could then use that same loop to find things that are this key ID, right? This particular one here. And I could say anything that matches that key ID, I want to take out, or I want to replace it with packages that I've signed with something else or whatever. Now, obviously, I'm not trying to say EPEL is not something you can trust. It's just the example I'm using. But maybe that's like Joe's pretty good RPM repo. And you're like, I'm not sure who Joe is, and I'm not really sure I want his packages installed on my machine. Now, there's another one here. I'm just going to copy and paste. You can use the same thing. If I could highlight all of the text instead of just the little piece here. You can also use a variant of the same command. If I use the right paste command, now I got ugliness. You can, so this is doing RPM-Q instead of QA. Q tells it, I want a specific package. QA says, show me all the packages. And then you can see at the end here, I put a package name. So we're going to check specifically who signed Vim Enhanced, right? So that's another way that you can say there's a specific package I want to check and make sure that it's signed by the right people. And you can do that right there. Or maybe you can do that through some loop or something, however you want to handle that. And
one
sorry, go
other
ahead.
option interested in, Nate, is
Mhm.
RPM-A Vim Enhanced. And you may need to throw a couple dash lowercase v's on there to make it more verbose.
What was it you were asking? RPM?
Capital K dash VV.
K dash VV. And then Vim
Yep.
Enhanced?
Correct.
Oh, there you go.
K is the GPG signature checking, and the GPG key is used for signature. And maybe the VV is too much. But
Oh, open failed. Oh, is this for an actual package? I do have a package here we can look at. There you go. So dash K works on a package handy.
Yeah, and notice that it says signature is not okay. That's because you don't have the GPG signature imported into the GPG keyring for. So this came from where, but you haven't explicitly trusted the signing key that was used for it.
Which is something you normally do when you're adding the repository to the system. The first time, after you add a third-party repository, the first time you run DNF, it'll be, hey, I don't recognize the key for this new repository. Do you want to accept it? And then you'll have to tell it yes or no. Probably yes, if you put it in there on purpose.
Yeah. All right, so we have one more problem I have seen in the wild a few times that I've set up on my machine, and that's I installed something from source. So let me clear my screen here. All right, so I downloaded some source code archives and I untarred them, and you like go into HTTPD, and then you do a configure, and I'll do a control C because I don't actually want to run it, and then a make, and then a make install. And at this make install step, it takes all the software that you compiled during the make step, and then it starts dropping it in your file and directory tree on the machine. The problem is this is unpackaged software. And if I had HTTPD installed on this machine, make install is going to overwrite some of the components of my installed HTTP that I installed with DNF with updated ones from this downloaded from Apache directly repository. Sometimes I've seen source code archives compile additional system libraries, and it replaces the system libraries with its own updated version, which then breaks all the other applications that were compiled with the original version of the library to be used. It's a mess. So when you are working with a package managed distribution, RHEL or Fedora or Ubuntu, you probably don't want to then also compile and manage source code, or compile and manage software from source code, because now you're mixing two things that don't necessarily go together. And there are distros like Gentoo where like it's entirely run by source code, and you download and compile and install source code based software. But if you're on a package managed distribution, you want to stick with the package managed software. And that's because as you make this and install it, it can potentially overwrite stuff on your machine. And the database where we're keeping track of all the package managed stuff has no idea that you did that. Right. So it looks like what Nate did earlier with Vim, where he overwrote it with another binary. And now things like the verification fails because it's not what we expect to be there. That's what happens. We have no idea why it happened or how prolific it is. And when you finally figured out that this is what happened, you might try to do a make uninstall to delete off the things that you put in there and then to work with DNF to try and reconstitute the machine. It's a lot of work. Just don't do it. The
Right.
reason I say doing this more likely is because they're looking for a piece of software and they can't find it. Right? I need, I don't know, Ethereal, or I need some Python library that is not included with the native RHEL.
Or a package that's newer, right? Maybe it's included with RHEL, but what you need is like the bleeding edge thing because you're doing something that you feel like you need the bleeding edge version of the piece, right?
It's because you were told by your security auditors you needed the bleeding edge thing because they don't believe in backporting. Don't
Right.
fall into.
Or the one I saw more was no, I need Python 3.x.y and RHEL only comes with 2.x.y because we're talking like the RHEL 7 or 8 days, right?
And
Before it was easy to get Python 3.
largely Red Hat has addressed some of this. Way
Yeah.
back, version of something that was shipped with RHEL was the version you had to have for 10 years. And starting with RHEL 7 and enhanced in RHEL 8 and 9, we now periodically drop newer versions of things. So newer
Right.
Python, newer Postgres's, newer Apaches, newer Nginx's, newer Golangs. And so you can actually do more cutting edge stuff. Maybe not as cutting edge as the most up to date thing from the project that's available, but definitely newer than what came with the original release of the distribution.
Right.
But the other place where I see it a lot is somebody's looking for something, they can't find it. So they feel like they have to download it and compile it
Yeah.
from source. The
Yep.
reality is there's a bunch of additional repositories like extra packages for enterprise Linux that Nate just mentioned that likely have that software. And one of the key things for extra packages for enterprise Linux is that it is a complement to those packages that come with RHEL. So it will not, as part of the packager guidelines for extra packages for enterprise Linux, they will not replace a package that comes with RHEL with their version of the package. It is only a complement to what comes with the enterprise Linux distro that you're running. And if that's the kind of situation you're finding yourself in, check extra packages for enterprise Linux. There's a couple other pretty large repositories too, like RPM Fusion, that you might find what you're looking for that you don't have to compile it from source.
And if all else fails, you can build your own RPM that will build the thing that your users want or that you need. And then you can sign it yourself with a key that you trust, right? So you know you built it, you've signed it with your key or your organization's key. And then when you install it, it will verify, right? So now it's not just some hokey thing that you're not sure where it came from. You can say, look, it's in the RPM database. It's signed by my key. We built it ourselves. We trust the build.
And that's if it's not already out there, that's the next thing to do. Instead of just trying to maintain the source code across all the machines that you manage, compile it into a package, manage the package instead. All right. So I think that runs us off our list of package things that we we're going to talk about today. But I wanted to tell a story about a new and young system administrator, Scott. When I started in system administration, I worked for someone who had an encyclopedic knowledge of Unix and Linux, and his name was Chris. And when I first started, I, of course, didn't know all the commands and didn't know all the options and didn't know what the RPM-V output looked like. And so I would go to Chris and I'd ask him. And that lasted for all of about a week. And after a week, I'd come in and go, "Hey, Chris, how do I?" He'd be like, "Did you look at a man page? Did you read a web article? Like, what research have you done on your own before you ask me this question?"
Did you check how to forge?
That did not exist then. Like,
Really? Wow, you're before how to forge. Okay.
So from my perspective, it was frustrating because I knew he knew the answer and I knew I could ask him and I'd get the answer and I'd scurry back down to my office and I'd type whatever command he had given me and it would work. But what he was really doing is helping me become self-sufficient as a systems administrator. So he could give me the answer because he knew it, or I could do a little bit of research myself. If it still wasn't making sense, he would absolutely help me. If I had 4 man pages, but I didn't know which one, or I tried to run a command and that option that I used didn't produce the output I thought, I could go down to him and ask because he had this encyclopedic knowledge of the system. If you are new to system administration and you have a old gray beard that works with you, or in some cases a half blue beard that works with you, and they're not always super helpful and they tell you to do your own things, they may not be doing it just to make you angry. They may be doing it to help you become a better system administrator by developing skills like how to read a man page, which is absolutely a skill, or what Google foo you need to develop to get to the article that tells you the thing you need to get to. So that's my old
Man,
gray-haired system
Google
administration.
Google foo is a marketable job skill nowadays, and maybe not so much now that we have AI that we can just say, "Hey, how do I do this thing?" and it tells us. But yeah, up until about, I don't know, 3-4 years ago, Google foo, half my job as a systems administrator was not knowing how to do a thing. It was knowing how to find out how to do a thing.
100%. And then also reading the thing to be like, is this really legitimate? Is this really what I
Right.
need?
Guy on Stack Overflow tells me that I need to do it this way. It really doesn't make any sense. Is really what I need to do? All right. So over the years, I've developed a little bit of a toolbox for things I use when troubleshooting. I mean, lots of things on a RHEL system, but these were a little more specific to services. And ever since, what is it, RHEL 7, we're in a systemd world. So these tools are going to be specific to systemd. If you're looking for a non-systemd tutorial, sorry. All right. So the first tool you're going to want to care about is Systemctl. Right? And if you just run it, it gives you this output. I don't know. What's this showing? It's actually showing us a whole bunch of things that Systemctl or systemd knows about. Running it like this isn't quite as helpful, except it gives you a nice summary, right? If you just look through this summary, you could find the service you care about and see its status and whatnot. If you really want to see the status of a specific service, there's a subcommand called Systemctl status. And you could do it on something like SSHD, because I know that's something that's already running. And it gives you this nice output. We're going to go a little deeper into this in a little bit. Another cool feature that I like about Systemctl is Systemctl edit. If you remember the old days of the old sysv init or system5 init, whatever, I know people can argue about what that's called, but editing the startup files for services was kind of tricky. This case statement that you had to figure out where you wanted to put your customization in. Some of them were written one way, some of them were written another way, some of them were nice and modular, others were just a complete mess. Systemd really kind of helps with that. And there's a nice subcommand called Systemctl edit. So if I do a Systemctl edit on mariadb.service, it's going to, oh, did I typo it? Oh, I did .server instead of .service. Copy and paste, folks. It brings you this nice editor in whatever your system's default editor is. In my case, it's the only editor that matters. And you can see in the comments here, it gives you some examples of things that you can do, and it tells you exactly where you should make changes at. It also tells you where these changes are going to get stored. We're not editing the actual MariaDB service file. We're adding in what's called a drop-in, which will go in this directory you can see at the top, etc systemd system mariadb.service.d override.conf, right? So I don't have a specific thing I wanted to add to this, but we're just going to take one of the examples from down here and copy and paste it up into here. Take away the comments. And we're going to save it. And now if I look in etc systemd system mariadb.service.d, you can see there's an override.conf that in there has exactly the thing that I just added. That's a little formatted funny, but you can work on that if you're doing this for reals. Honestly, I don't actually want that there. I just want to show it to you to show you where it gets written to. We're going to get rid of that. All you have to do is delete the file. And now if I go back into Systemctl edit, you'll see that it's back to the empty state that it was in. So there you go. I think that's a really cool feature and really handy if you're going to modify the way a service starts, or if you need to put some boundaries around it, or if you need to say, you know, what order things start in, whatever. Systemctl edit. All right. So the next cool thing is Journalctl. Systemd stores the outputs of a lot of things that it runs and manages in the system journal. You might say, how do I read the system journal? That's where Journalctl comes in handy. So Journalctl all by itself will just give you the output of the system journal. I like to pass in -xe, which gives it extended output, and I think it improves the way the pager works, if I remember correctly. And now you can just kind of scroll through here and look for things that are in the worldwide system journal. There's other ways to look at services specifically, but we're going to go into that a little bit later. All right, the next thing I like is SS, or in the old world, it was netstat. So SS will show you all of the open sort of sockets on the system. If you do, I like the command line -tulnp, which will give you a nice summary of TCP and UDP connections. It'll show them by the numbers. It shows you what process is running on that port, things like that. There's a good way to tell what ports are open on your system, and if a port is available for use, or if there's something that's already using that port, right? It's kind of the same thing in different words. And in the same vein is netstat, or not netstat, I'm sorry, Nmap. Okay, Nmap is a tool that is used for network scanning. Now you might think, oh, this is like some hackery realm that we're going into. This has a really valid use case for people who are trying to either secure their own networks or simply see whether they can reach from one system to another, or if they want to see what ports are open on the system that they're currently on. Nmap, if we just like nmapped on localhost, you'll see what ports are open from localhost to localhost, which should be just about anything. The firewall doesn't usually stop anything from getting to localhost. But if you were trying to see what the server next to you had open, you could use Nmap to see, is there a firewall blocking me? Is the service listening? Can I reach that thing? This is a good first layer of troubleshooting. A couple other good examples. Sorry, do you have something you want to say?
Yes. You talked about scanning the server next to you. That goes through your network, and there are places where Nmap is forbidden to be used. And you probably want to give your network administrator team a heads up using it, because what it really does is it sends a connection request to like 1,000. And so to a lot of like intrusion detection software and stuff, that looks like an attack, which is why many places forbid using it across the network to scan other machines, is because it goes across the network and then it triggers all of their intrusion detection stuff.
Yeah, very valid point.
That is for Nmap. SS, not a problem.
Yeah, SS is for local connections. Nmap is for remote connections. And you're right. If you start using Nmap en masse across your network, or even just to scan one or two hosts, it might get noticed by your information security folks. However, there are some ways to sort of limit the scope of what it's scanning. And that's exactly what I was going to show next. If you're trying to find out specifically, right, maybe you're on the web server and you need to see if you can reach the database. Instead of using, I mean, you could use the client tools for the database, but let's just use this as an example. You can use Nmap to scan one specific port. Now you use the -p command for that. We're going to use 22 because I'm going to look at SSH, and we're going to look again at 127.0.0.1 only because that's the only host I can scan at the moment. I don't have another host to poke at. And this will send that same request, but only to one port, which won't look quite as nasty to your information security folks. Still, if you're going to be using Nmap, heed Scott's warning. Maybe it is something you want to ask about. There's two other things I want to show you quick with Nmap, and then we're going to wrap up the critical path. This is checking specifically for TCP, right? So is a TCP port open? But not all services use TCP. What if you're trying to look at UDP? If you do an Nmap -s with a capital U, and then again, we'll do localhost. It's going to come back with nothing. Oh, sorry, NAMP. We're going to NAMP instead of Nmap. I don't know what a NAMP is. It sounds kind of like a nap. I'd like to take a nap. Okay, and it comes back with nothing because there's no UDP sockets open on this particular host. One thing a good example of a UDP request would be DNS. So we can just do a quick Nmap against the DNS server to show you what this is going to look like. So we do SU. You can still use that -p command that I showed you before. This says just look at port 53, which is where DNS would live. And I'm going to check Google's public DNS server. And maybe I'll get my server blacklisted or something for doing this. But there we go. You can see port 53 is open. I can reach it from this host. And that would tell me that, connectivity on port 53, unless it's otherwise limited through some kind of an access control list within the DNS service that is, or whatever service I'm connecting to, I should be able to connect to that port. So, did I miss any tools? Any questions about tools?
So Nate, I've got this machine that I've got Apache installed on. And I decided that for our busted services, I'd actually just keep busting the same service so that we don't have to worry about the vagaries of like how services work and can instead focus on some of those symptoms that one might see and then how one diagnoses and resolves that. So I've already got this machine or this service broken. And if we try to start the service, it doesn't work so good. And it gives us an option to look at the Journalctl. So if I put in the Journalctl command as suggested, this is what we get. And we actually get a couple of interesting messages through the Apache logs. Specifically, I want you to direct your attention to these two lines. So one of the more common causes of services not working is, guess what? Somebody put the wrong stuff in their config file.
Somebody messed up the config.
And that's exactly what happened here. So you can see Apache is great about this. It tells me where the line number is that the syntax error is on. A lot of them will just say like what the syntax problem is, but not give you the location of the file. And then it even diagnosed it for me. That's how awesome Apache is. So it says port was replaced with listen in Apache 2.0. So maybe I was using an old thing, or I read an old document that I found at some horrible website on the internet. And let me go ahead and open up the file. Line 47. So right here is where my syntax error is telling me I have a problem. And you can see the section above says that this is for a directive called listen. And listen is what port number the service attaches to when it starts up. But instead of using the listen directive, someone put in port, which used to be the way you did it way back. And other services will use the word port to describe the port number that they want to be configured on. So it's a fairly common problem that somebody puts the wrong thing in there. All right, so listen, and let's see if we fixed it. That seems good. Let's look at the status real quick. Oh, sorry. Start status is not the right status. All right, cool. So here we are, we're active. So it's running, and we could actually probably connect our web browser to it and view the test page or whatever web content we've got in place for it. So Nate, what troubleshooting diagnosis did we do to find that problem?
Well, we asked systemd to give us the output of the journal for that particular service, which was sort of what I covered earlier, except you specifically said, show me this unit file. That's what the U after the XE was for. And Apache was pretty direct about, hey, this is where your error is. Go fix it. You fixed it, restarted the service, and up it came.
Yeah, and a lot of services on Red Hat Enterprise Linux and other Linux distros will not just use journal D for their logging, but they'll also use syslog for their logging.
Yeah.
And so it turns out if we did a tail, let's see, 30 from var log messages, looks like I had too many messages come in its place. But you can see that there's some Apache related messages in the varlog messages file too. So you don't just have journalctl, but journalctl with those arguments allows you to focus on specific messages a little bit easier. Not every service uses journal D, and then things like log aggregators may prefer syslog. So syslog is still a place to look as well.
And Apache, much like many services, is one of those where some some system level errors will end up in the journal or in varlog messages or maybe some other filtered out syslog controlled log file. But then other errors, once the service is running, will show up inside of the actual output from the service, which may not be in the journal or the system log. It'll be inside of wherever you told the service to log to, right? So in Apache's case, it's usually it's usually var log httpd, depending on your system, right? There's other places that could end up.
And hopefully everyone was listening to Nate's explanation and they were in no way watching the man behind the curtain break the service in yet another and different way.
Did you forget to turn off your screen share again?
Well, we felt it would be remiss if we didn't cover this next one, but I'm not going to cover it in a ton of detail. But our troubleshooting methodology is going to kind of look the same as what we just saw. So I'm going to systemctl start Apache again. If I spell it right.
Now your system's in a cult. System cult.
Hold on, I didn't break it in the right way.
How dare you?
Yeah, maybe we could toggle off the screen share and I'll break it real quick and then we'll
Pay no attention to Scott breaking the system live on the air. So,
right.
yeah, the transition from the old way of monitoring stuff through syslog and into the new world of journal, systemd journal, was definitely kind of a stark difference for me when that came with RHEL 7. So I'm sure I'm not the only one who had to learn how journal control worked or journalctl. And Apache specifically, I was doing a lot of web hosting at the time. So
Okay, now I've got it appropriately broken. Let's take a look at it here. So I'm going to do the same start. And again, we get an error message, and it's the same error message because there were problems starting the service, and so we're directed to the logs to kind of look at what's going on. I need to copy and paste more, Nate.
well, CTL is difficult to type. Every time I type it, I always like think I'm getting it wrong. And Systemctl, Journalctl, they're just difficult commands.
All right. So here's our error message. Cannot bind to address something, port 8000. So basically, the way that many services work is they will scan your machine's configured IP addresses and then attempt to bind to the same port across all of them. And so to reference what those IP addresses are, that's where you get this kind of like wildcard IP address. So
Hmm.
for 6, that's square brackets with 2 colons. For IPv4, that's 0.0.0.0. So our service is configured to listen on port 8000. That was what I was breaking. And then we get this error message that says permission denied. So Nate, what would we check first when we see things like permission denied?
I mean, I don't want to go right to the thing I know is the answer, but I don't know what else I would tell you. So this basically means that something on the system has prevented Apache from attaching to that particular port. And there's only a couple things that could do that. One would be, I guess, if you were running Apache. No, I guess even still, if you're running Apache as a non-privileged user, it would still be able to connect to 8000 because it's a non-privileged port. But it's probably SELinux because I know you're running it as root because I don't think you changed that. And you're on a non-privileged port, so it shouldn't care. So yeah, SELinux. Good old SELinux. Just turn that stuff off.
And no, don't turn that stuff off.
Don't turn that stuff off.
And when we look in varlog messages, we actually see more explicitly that it's SELinux that's blocking it, right? Because this machine is running set troubleshoot D. And so when the SELinux violation occurs, it very helpfully says, oh, by the way, this is what you could do to fix it. But if you read the messaging here, it says that SELinux is preventing that service from binding to port 8000. And then it tells you how one could fix it if they wanted to.
Right.
But I don't want to go into a lot of details with SELinux, but attaching to non-standard ports for services and SELinux tends to be a problem because SELinux has like a list of ports it expects to find certain services on.
Right.
You vary outside of that list, then all of a sudden, like it's going to stop your daemon from attaching to that port number. And so instead of turning it off, instead, if you are interested in more this realm of troubleshooting, we have 2 previous episodes that we covered in depth on SELinux. One is kind of a basic thing on SELinux and how it works and how you can do things like add ports into your SELinux port mapping. The other one is a little bit deeper into SELinux troubleshooting, which includes making updated policies so that when you reboot your machine, that all of the rules that you've put into effect are still there on the machine. So I would refer you to those 2 previous versions of Into the Terminal if you want to go further. But to fix this one just real quick, se manage -p, man, I think it's -a. I'm going by from memory, so of course it's not going to work. All right, se manage port. Still not. All right, I'll leave it be because I'm going from memory and that's never going to work.
This
But
reminds me of a previous episode. Goes by the name of Sudo.
invoke the forbidden episode.
The forbidden episode.
Yeah. So it could have also been that we typoed that, right? We typed 80, but we ended up hitting some stray
Yeah.
characters in VI and it ended up being 8000. But notice that if we change it back to port 80, man, having a rough day today, Nate.
Start goes first.
It works just fine, right? So now we can systemctl status HTTPD, right? And it's active and running. So trying to bind to a non-standard port can cause problems, maybe through SELinux, maybe because you typoed the thing and that's what's triggering SELinux, but that would be something to take a listen or a look at as well.
And you might wonder, like, why does SELinux care if Apache is running on 80 versus some other port? Like, why is that a big deal? Why do I have to be limited in that way? And that's because you've got a server that's running or that has Apache installed, or maybe it didn't have it installed, and an attacker hops into your machine and has shell, and they want to try to exfiltrate stuff from your machine. They might try to start up Apache on a port that you aren't looking for and pull that data out through there, right? So this would prevent them from doing that, or help prevent them from doing that. One more layer.
All right. So I did want to just cover off on without SELinux, we can also have port problems. So notice that I temporarily disabled SELinux. And we're going to change it to listen to another port. And now when I do let's make sure it's stopped with the old config, and then we're going to start it back up with the updated wrong config. Right? Again, it's broken. And if we look at the Journalctl, we get this one. Now notice that the error message here is a little bit different. Before, when we saw the SELinux functionality stopping the binding, it said permission denied. Now it says address already in use.
Totally different error.
Yeah, something else is attached to port 22, and that's why it's not allowed to attach to it. And so what might be interesting is to know what's listening on port 22. And so one of the other tools that Nate showed us earlier was socket status. So if we do an SS TUPN, and we're just going to grep that for port 22. All right, we're told who is bound to port 22. So the reason that Apache can't bind to port 22 is because SSHD is attached to port 22. And while port 22 is a pretty well-known port, and I'm sure many of our viewers, when they saw me change it to port 22, was like, oh, that's not going to work. That's going to conflict with SSH. Realized that that could have been any other port that some other service was attached to. So you use tools like an SS command to see what's out there, what's listening on that port, so that you don't generate a conflict where your service is trying to attach something it's already attached to. All right, another variation that's becoming increasingly common on port problems is containerization of services. All right, so before the show, or maybe even during the first part of the show, while Nate was telling us about the tools that we were doing, I was building this enterprise Linux web server container, right, called EL HTTPD1. And I built it as a non-privileged user. And it's a better security practice to attach services or to run containerized services as unprivileged users. That way, if something were to go crazy and it breaks out of its containerized environment, it's running around on the system as an unprivileged user, as opposed to running around on the system as root with all the rights and privileges of root. So I created this Apache container as the RHEL unprivileged user account, and I can run it with Podman. And so we can look something like this. Let me try one more time. All right. So we're going to do a Podman run. We're going to run it in a disconnected mode. So it's got daemons. It'll just run out there on its own. I'm going to give this port mapping, and here's the name of the container that I want to run. And this is what we get. So we can't run that container because as an unprivileged user, you are not allowed to attach processes to port 80. And so that -p syntax there basically says, I want the system's port 80 to direct traffic to my container. And then on my container, I want it to direct traffic to port 80 running inside my container. So inside the container, I have an Apache daemon running and it's attached to port 80, and the container host is actually directing traffic from one port to port 80 on the container. And so one way we can address this is say, okay, we're going to attach to port 8080 on the host, right? So we're attached to a non-privileged port, which is anything over port number 1024. And unprivileged users are allowed to attach to port numbers greater than 1024. So I attach incoming traffic to the host system's port 8080, redirects the traffic to my container's port 80, and that's how I get traffic into the machine. And so I may then have to go to things like firewall rules and other stuff to make sure that traffic is directed to this port number as it hits the machine. And so you still require a little bit of root intervention to make that adjustment. Alternatively,
I sometimes wonder how important the privileged versus non-privileged ports thing is anymore. With the advent of SELinux and just in general, how many services run on what you'd consider non-privileged ports anyway? I don't know if anybody's thinking hard about that question, but I wonder every time I have to do this.
yeah, and so that's actually where I was going is, let's see. Nope. Nope. There it is. So in proc, sys, net, IPv4, IP unprivileged port start. So the reason that unprivileged services can't attach to any ports below 1024 is because there's this setting that says they're not allowed to. So instead, if I do this, basically I'm saying privileged ports are from port 1 to 79. And anything above port 79, regular people can attach to. So if I again become root or the RHEL user, and I run that podman command to start up my container and bind to container hosts port 80, directs to containers port 80. Remember last time that failed. But now it doesn't. Oh, except yeah, except now it doesn't. So right here, I'm running my container, and you can see that it's attached to all the IP addresses of the host port 80, and it directs to port 80 inside my container.
Right.
So to Nate's point, like, what are we protecting from running as root? And there are valid reasons why you would not want to do that, right? Maybe you want to make sure that if somebody connects to port 80, you know that it is a system service running on the container host, and therefore it can't be redirected to anyone's web server running a container on the host. But that's one way to address people running services on the host that need to address or be connected to privileged ports, is to change what those privileged ports are in the system configuration. The change that I made to procsys is not persistent. So if we were to reboot the machine, it would go back to port 1 through 1024 would be privileged. So you would have to persist it using either a mechanism called syscontrol, make sure that it's persists between reboots, or you could use something like a tuned profile to make sure that change was persistent between reboots. But that's another option. All right, let me toggle off the screen for just a moment. And I have one last break to show folks.
So now's a good moment to remind folks we have a Discord community. If you aren't already in there, there's a QR code at the top of the screen. You can scan that, get the invite, which should work, although we've heard some folks say it doesn't, but every time that we test it, it does. So if it doesn't, I guess reach out somehow and we'll figure out why you can't get in. But me and Eric hang out in there, a couple other viewers hang out in there. Yeah, we're trying to build a nice community around the show. So hop in there, that and the RHEL Presents folks. Anybody who likes our content, we'd love to hear from you that way. Interact a little more.
Uh-oh, Nate, I may have broken my machine in a new and interesting way.
Did you break it in the way you did not intend?
Yes, I broke it in a way I did not intend.
Well, how about while you fiddle with that, I'll talk about how to enable services at boot. What do you think?
Yes, let's do that.
All right. Okay, so you've got a new service installed. In my case, I installed MariaDB, same service that I used in my example during the critical path. But now you have to make sure that it starts at boot. So first of all, obviously, I'm not going to add the dot service. If you leave off the dot service, it'll make an intelligent decision as to what it is that you're trying to call. In this case, it defaulted to the dot service, but you can call things directly. There's sockets, there's services, there's timers, there's all kinds of stuff. Anyway, you can see here that it says that it is inactive, right? You see where it says active, inactive, dead. Poor MariaDB is dead. Long live MariaDB. And it tells me what unit file it called for. And to see this disabled right here, that means that it will not start at boot, right? Now we can still start it. Okay, and what this will do is it'll start up the service. And then if we look at the status again, it's going to say, hey, it's active and running. Yay. But it still says disabled. So now if I were to reboot this machine, which I'm not going to do now because that would take a few minutes to reboot and it's just a waste of time. But trust me, if I were to reboot this machine, it won't come back up at boot. So let's stop it again quick because I wanted to show you one other command that's actually really nice. So there's a command called enable, systemctl enable, which basically takes it from that disabled state to a enabled state, which tells it, yes, this thing should start at boot. Now, you might think that disable and enable means the service is disabled, as in you can't start it. That's not what it means. It means that it is enabled at boot versus not enabled at boot. So systemctl. See, people who are telling me about tab autocompletion, look, system, if I hit tab right now, there's like 100 different things that start with system. So don't tell me tab completion is the answer. Systemctl enable MariaDB -- now is the extra thing that I wanted to show you. So now says don't just enable it, because if I just did systemctl enable MariaDB, and then if I do the status again, it says, notice it's still inactive, but it's enabled, which means if I were to reboot the server, it'll come up when I boot it, but it doesn't start it when I run the command. So now I would have to do a systemctl start, which means I have to do two commands. Now, let me just disable it again. And you can see in the status again, now it's disabled. If I do the same enable command, but I add -- now, it'll tell systemd not only to enable it at boot, but also start it right now, right? So now and you can see there's actually, the way it knows to start them or not is there's just symbolic links that are placed inside of the proper directory structure within systemd that tells it these are the services that I want you to start at boot time, which you might recall is very similar to the way it worked in the old init system, right? There were you put a link to the script files inside of the different run levels you wanted them to run in. Well, this is same concepts, except systemd uses targets instead of run levels, and it uses different types of service files. But I digress. If I do status again on MariaDB, you'll see that not only now is it active, as in it's running, it's also enabled for boot. So that's a good trick, especially if you're trying to automate this stuff. If you want it to start and enable the service right during your automation, you can add the dash dash now flag to the enable. If you do not want it to start immediately, you just don't use the dash dash now flag, and there you go. Okay. Nate is not dominating Systemctl. I don't know what that means, but okay. Okay, and the other thing I was going to talk about was the journal, but we kind of talked about the journal pretty in depth already. I don't know what else to cover there. So, are you ready for your other demo now, Scott?
Yes, in a very oxymoronic way, I'm going to say I have a working broken machine.
I have a working broken machine. Good.
All right. So this is one that I have encountered occasionally. So I'm going to show you what it looks like and we'll troubleshoot it. But this is kind of one of those like, I've done all the normal things and I still can't figure it out. Let me check this last thing. So if I systemctl start Apache, we get this error message, right? No surprise because I said that I had a broken machine. And here we go. Oh, we're back to line 47. We saw this earlier. Well, let me take a look at this.
Yeah. Port must be specified. Oh, this time you forgot the port. Well, go in there and specify a port, Scott. Come on.
All right, I'll do it. Just
you got to tell it a port. If you don't tell it a port, how's it know where to start?
All right, so we're going to go down to listen. Right, there you go. Nate, it looks like I specified the port number.
Yeah. So, I mean, my very trained eyes indicate that there's 2 spaces between listen and 80, but I don't think that HTTPD cares that much about white space.
Okay, it doesn't, but you know what? I'll just delete one of those spaces. There you go.
Okay? You think that'll fix it?
I don't know.
I mean, you know whether it's going to fix it or not, but I think it should. Oh.
Nope, sorry, not fixed.
Well, what's the journal say now? Is it a different error?
Good question. Yep, line 47.
Oh, wait. What's that? Listen /XA080? That's not what was in there.
That's weird. Let's look at it again.
That is weird. That was clearly a space.
Right, so here we are. Listen 80. I don't know what's going on here.
That's a strange one. So personally, what I would just do is nuke the whole line and retype it. But I think you've got something else up your sleeve here.
Yeah, so what I'm going to do is I'm going to cat that file. So we know what the cat command does. It just concatenates a file to the screen. But the VET options, actually, it's really only one of those matters. But I like spelling it as VET because I can remember it easier because you take the cat to the vet.
You're taking the Apache config to the vet.
That's right. What it is, it will show you unprintable characters. So when we look down at listen, this like after running it through cat vet. So that thing that we thought was a space is actually not a space. It's this meta dash space in a thing.
That's interesting. I don't even know what you would use to make that, but okay.
It was incredibly difficult but it doesn't always have to be incredibly difficult, and it's kind of weird. My first time encountering this was when I was writing code as an undergrad, and I don't know whether it was like a hiccup in my connection to the machine on the network or what, but a stray control character got shoved into my source code. And I kept getting errors from the compiler about bad syntax on a specific line, not unlike what we just saw Apache complaining about. And I actually did delete the line and put it back in by hand and still no. But it turns out it was at the end of the line. And when I deleted it, I literally used the character deletion to like remove all the content of the line, not recognizing that I had this extra space, what appeared to me to be a space at the end, that was actually this weird control character. So let me go back into the file and we'll edit that out. So we'll remove that and put in space. Oops, that's not what I wanted. Let's do our systemctl again. Right now it starts up just fine. So control characters, or actually a variety of unprintable characters, can sometimes make their way into your files. Now, probably the most common way to get this is something like you edited the file on a Windows machine, or you use the integrated into GitHub editor for making a quick change to a thing. Well, it turns out both those editors use carriage return and line feed characters to indicate the end of a line, which, if we were to look at it with catvet, would be displayed as a control M is the carriage return. And
Yep.
then there's another character, which is a $ for the new line character. And as I was experimenting around those, when we talked about it on Monday, I was like, oh, I got this. And that was my plan. I was going to Unix to DOS a file and break my stuff. And it turns out that a lot of services and applications on Linux boxes now are quite happy with carriage return line feed files. So that didn't work out in my favor. So I had to go and like find another unprintable character to shove into this file to create this problem.
I tell you what, Scott, they keep taking all the sharp edges off of everything anymore.
I know. Why are things easy to use and forgiving?
Yeah.
But so there's a tool called DOS to Unix, and I see that Vincent mentioned in the chat. So that will take a Windows formatted file that has control M's and returns in it, and we'll convert it over to a Unix system. And it goes the other way too. So let me, in my terminal, I'll go ahead and DNF install the DOS to Unix package. And it's to do this conversion to return or to remove those extra characters. So if I do a Unix to DOS on this file, see here at the end of every line is this control M new line. That's what files edited on Windows, like GitHub editor, will add. And so to get rid of it, you just convert the file using DOS on the screen, DOS to Unix on that file that has that format, and it will replace it. Right. And now when I catvet, I just have new line characters.
Right.
I don't have that control M anymore. But DOS to Unix doesn't care about those other weird ones that we had in our file earlier that looked like a space because the terminal could not represent it with a character. And that's why it just got shown as a white space character. For that, you need to use something like cat to cache. There's another super old tool called OD that can also do that. It looks like this. Sorry, OD-C.
I see billboards all over the place about OD. I think that's a different OD though.
So what this is doing is actually showing you every 8 bits, or I should say every character, every 8 bits. So when I originally ran it, it was just all numbers because it was showing it to me in octal. So OD-C shows me the character value for each 8 bits. And this
is super easy to read. I'm glad you showed me this tool.
Right. That's why you want to we're all coming full circle. Use cat-vet because then you can actually see the file as it exists in a much more sane way. But back
I don't remember them off of
that.
I don't remember them off the top of my head, but I think that both Vim and Emacs have commands that will show you hidden characters within the editor as well. So that could be helpful in some cases.
Could be. And it turns out that Less actually does some stuff with a wider character set than VI uses. So while we opened that file in VI and we couldn't see it because it was represented by white space, when I looked at that file that was mangled with Less, it actually had a weird blob of characters in there that it represented. In fact, I could probably just pull that. Let me see here. Yeah, so you can see here is my original file I was using, and it has it in there. And if I do a less, right, it shows it as this weird highlighted character something something, but it can't find every character that way. So cat-vet is still the arguable king of showing unprintable characters in a file. And I usually combine it with less so I can see it one screen full at a time as I'm looking through it. All right, so when all else fails, when you're like surely sure that everything is correct, that's a weird one that occasionally does happen, and you'll get to enjoy taking your cat to the vet with the
Yeah.
file.
Good stuff.
All right. So that kind of runs us off the end of our prepared remarks. I saw a couple things in the chat earlier in the episode. Somebody asked about journal D being persistent. And I know that at one point journal D was not persistent. I haven't checked RHEL 9 to see if it's persistent on RHEL 9, but it was not persistent by default on RHEL 7.
Memory tells me that it's not persistent on RHEL 9, but I would have to go check. I'm not certain. I know there is an option that you can turn on that will make it persistent. And there's also ways to get it to log to like a third party, right? So you have it stored. But yeah, I think, well, I don't want to say much more on it because I'm not certain, but I think it's not persistent on RHEL 9.
Yeah, and I saw a Reddit thread a while back where somebody was expressing frustration that it was not sent by default. And it's like, well, one of the reasons why it's not is because we still use syslog, because
Yeah.
syslog has really good integration with other log aggregators like Splunk and other stuff. And if we persist the journal log, we are essentially logging every message twice, once the journal log and once to the syslog system. So we chose to only log it once by using syslog and leaving journal ephemeral. And if that's not what
Right.
you want, you can certainly persist journal. But along with that comes things like, how are you managing those additional logs that are now perpetually growing because they're persistent on your machine, right? So if you're going to do that, then make sure that you account for it with things like log rotates and other stuff.
Yeah.
And then if you wanted to make it persistent by default, you can just like throw it in your Kickstart file or something else that will run the configuration to persist it.
And we've talked a whole bunch about syslog, and we haven't really delved into it. I don't intend to delve into it, but just if you're not familiar with syslog, there is a daemon on your system called rsyslog, which will take journal or log entries from the logging. What's the word I'm looking for? There's like a subsystem, a logging subsystem, and it'll do what you tell it to do with them. We've told it to write to files, but you can tell it to do lots of other things. So it's something that you can keep in mind. You can have it write to a third party. You can have it write to a different rsyslog server. There's lots of different ways to deal with those logs. Normally, they're written to those files inside of rlog. So just something to know about.
All right. I didn't see any other comments or questions. Nate, did you see any that were insightful or something that we should cover before we sign off?
I don't think I did. There was a little bit of snark, a little bit of commentary, a little bit of fun. I didn't see much in the way of questions. So if we missed your questions, please feel free to leave them as a comment after we're done, and we'll get back to you with a comment afterward.
Right on. All right.